Welcome to your Unreal Engine 5 one-course solution for Niagara VFX. In this course, you're going to learn how to create different types of VFX like proto effects, rain effects, projectile effects, waterfall effects, energy strike, character disintegration, and much more, and we'll start from the basic. In the first section, you're going to learn all the basic stuff that you need to know about Niagara by creating the standalone effects, flamethrower. We're first going to cover the different emitter stages inside of Niagara, then start using the sprite renderer to help us to get more familiar with different Niagara modules. After that, we're going to look into how to create our first VFX material so that we can apply custom textures to our VFX. Then we're going to go over how to use sub-UV animation and start to create this flamethrower with the heat distortion. Next, we're going to learn how to use mesh renderer in Niagara and how to create custom meshes in Blender for our VFX. More than that, knowing how to use ribbon renderer is also essential for us to create the VFX we like. We're also going to go through some of the basic coding principles in Blueprint and start to use that blueprint to bake out textures directly in Unreal. Then, with the tool we have, we are going to create different types of noise textures like Perlin noise, caustics, cloud, and marble noise for our future VFX. With all the knowledge and skills we have in the second section, we're going to create different types of VFX like proto effects, heat impact effects, butterfly effects, meteor attack, laser attack, energy strike, and projectile effects like blaze slash and flying sword. We'll begin with these proto effects and start modifying our master materials created in the last section to support more VFX features. Then we'll use Blueprint to create a VFX spawner and use it to spawn this heat impact surface and heat impact body effects. After that, we'll discuss the three most important stages a VFX must have in order for it to be complete by creating this meteor attack. We're also going to dive into Blender to create a VFX mesh for it and apply all the things we learned so far to the laser attack after it. Then we'll go over event and event handler and use location event to create lightning hit and energy strike. We're also going to need the dynamic parameters to drive the material data from Niagara directly in order for us to better control the different properties of this VFX. After that, we'll go into Blender and create a projectile mesh for our Niagara and use Blueprint to help us spawn this blaze slash and flying sword. In the third section, you'll learn how to create follow the leader effects, rain effects, waterfall effects, different dissolving effect for texture, static mesh, and skeletal mesh. We'll start with all the basic concepts that you must know for creating a custom Niagara module. Then, with the knowledge on Niagara parameter namespaces, we'll create this follow the leader effects. Then, with a little bit of vector math and some calculation in our own custom modules, we're going to create a more advanced version of it. Then, with all we've learned, we'll look into how to create this rain effects. We'll begin with the Fresnel effect and how we can use it in our material. Then we're going to build a master material for liquid and use this material to create raindrops, rain splashes, ripples, with the help of collision event. We're also going to handle the particle spawn on the slope using collision normal and dot product in order to have a better rain effects. Besides that, you'll also learn how to create custom Niagara enums and how to use this enum in our own custom modules. Then we'll look at how to use all the skills we've gained at this point to create this waterfall effects. We'll start with creating a waterfall mesh, then a waterfall master material, and use the caustic textures we created in the previous section to create these waterfall effects. After this one, we're going to dive into dissolving effects for texture, static mesh, and combine them with distance field and our custom modules to create this dynamic character disintegration. This will be the most comprehensive Niagara course that you'll ever find online, and the applied tasks in different lessons and section challenges in every section are going to guarantee you to understand every step along with reproducing it. What you're still waiting for, come get your one-stop solution for Niagara VFX, and I'll see you in the course. Welcome! Before we dive into Niagara and start to use it to build our VFX, let's discuss what a VFX needs first. So take this VFX for example. To create it, we need to do it through two different parts. So the first part will be the Niagara part, and the second part will be the material part. So these two parts, they are equally important, as one won't work without the other. So let's talk about Niagara first. What is Niagara? Well, I'm sure you know what a blueprint is. So by bringing our nodes by connecting pins inside of blueprint, we can use this to program our gameplay. So for blueprint, it uses something that's called the graph paradigm. So in blueprint, we are writing code inside of a graph, and we use the nodes and pins to do that. And same thing goes for Niagara. So this is a Niagara emitter. So same as blueprint, inside of Niagara, we also need to program how the particles should behave for the VFX. And unlike the graph paradigm, this is something that's called the stack paradigm. And here I have no intention to carry on the debate for which one is better. I think they both have their own pros and cons. For example, the graph paradigm can give users more control over the behavior, while the stack paradigm, it provides better modular behavior and readability. So we already know that in Blueprint, we write code through the nodes and pins. But how do we actually write code inside of Niagara emitter? Well, we do that through something that's called a module. So all the white text here, they are modules. And inside of Niagara, we use module to help us to write code. In Niagara, we are overlaying these modules on top of each other. So it's like putting things on a stack. And each one of these modules contains the code we need for programming the behaviors of the particles. And now you might be wondering, how do I know which module to use when I'm working inside of Niagara? Well, how do you know which node to use inside of Blueprint? I think the process is the same in here. So we first need to get familiar with the nodes in Blueprint, then we start to use them to create some stuff we want until we are comfortable with them. And same thing goes for Niagara. So our top priority here is we need to get more familiar with different modules. And this is the thing that we are going to do in the next section. Alright, now that you already know what Niagara is, let's talk about the material side of things a little bit. So Niagara here is directly responsible for defining the movement of these particles, and we can even use it to alter the shape of the particles, the color of it. But the material here, it directly determines the look of this VFX. So these two, they rely heavily on each other. So when building a material for Niagara, same with building a material for anything else, there are two things we need. So first, we'll need a texture. Then second, we'll need to use nodes to build up the logic for how we want to display this texture. And a VFX material is slightly different from a normal PBR material that we use in Engine. And don't worry if you find creating materials intimidating, as we will be creating a lot of them in the lectures to come, and you'll become comfortable with it very soon. In this lecture, we talk about the roles of Niagara and material for building a VFX, and we also discussed the modules in Niagara and what a module actually means for a VFX. And we also went over the material for Niagara and why it's so important. This is a great beginning. I'll see you in the next lecture. Welcome! Let's start with creating a VFX project for us to work with. So I already have my Unreal project browser opened, and I'm gonna select this blank to begin with. I already have the project location specified, and I'm gonna name my project Niagara VFX, and I'm gonna click Create.
Alright, after creating the project, here I am. So this is something that you should see in 5.1 when you create a new project. And instead of using this open world map, I'm going to create a new map. So I'm going to go to File and click New Level. And I'm going to select this basic level and click Create. Alright, first things first, I'm going to save this map. So I'm going to go to File and choose Save Current Level as. In my content browser, I'm going to create a new folder. And I'm going to name this folder to Maps. And double click to open it. I'm going to name this new map to Niagara Basic. And click Save. And after that, I'm going to use this map as our startup map. So I'm going to go to Edit and click Project Settings. Inside of Project Settings, I'm going to go to Map and Modes and change this editor startup map from this open world to Niagara Basic. As we proceed, we'll need to create different maps and we'll need to change the settings here from time to time. Alright, I'm going to close this window. And next thing that I like to do, so instead of using this plan as our demo room, I like to import some assets for our demo room. So I'm going to first delete this default plan. And in the resources dropdown of this lecture, you should be able to find the zip file, download it and extract it. I've already done that. So you can see there's this folder called Demo Room Assets. So I'm going to select it, copy it, and double click to open my Niagara VFX folder. And inside of the content folder, I'm going to paste the folder in here. And just like that, now we have some assets for our demo room. And to use it, it's very simple. You can just double click to open this folder. And there's a folder called Demo Room. Double click to open it. Now inside of this blueprints, these are the things that we need to use. So there's one that is called BP Demo Display and another one called BP Demo Room. I'm going to first drag out this BP Demo Room. And you can see I already have a room inside of my level. So this is the default demo room from Epic. And I think it's perfect for our purposes here. And I'm going to also drag out this BP Demo Display and place it in our demo room. So later, we're going to use this as the placeholder for our Niagara VFX. So first, I'm going to rotate this display a little bit, something like this, and I'm going to move it to the wall. All right, something like this. And now I'm sure that you have noticed that the scale of our room is a little bit off, and I like to adjust that. Having a correct scale to begin with is extremely important, as they'll help us to get the size of our VFX right at the beginning. Otherwise, we'll spend a lot of time in adjusting their scale. And to do that, we'll need to use a reference. So I'm going to go to Add and choose Add Feature or Content Pack. So I'm going to add this third person to my project, and I'm going to use the mannequin inside of it as a reference. So I'm going to click Add to Project. Alright, after importing the third person content to my project, I like to order their folder structure a little bit. So you can see I have 3 folders added, and they are called characters and level prototyping and this third person. I like to move this characters folder and this level prototyping both into this third person. So first I'm going to go to File and click Save All. And I'm going to drag these 2 folders into this third person and click Move here. Alright, that's the moving done. And if you are like me, that you are seeing there's a folder left, and once you are sure that there's nothing inside of it, you can go to the content folder and click this Fix Up Redirectors. So after we move a lot of assets, it's important for us to do this in order to clean up all the redirectors inside of our folder. And now we can safely delete this folder. So I'm going to press Delete and choose Delete. And now you can see that folder is gone. Alright, next thing, I'm going to go into this third person, go into Characters, and go to Mannequins. And go inside of this Messages. I'm going to drag out this SKM Many Simple. And I'm going to use this as a reference for my room. Alright, I'm going to leave this mannequin a little bit, something like this. And you can see the height of our room is a bit off, and the height for this display is a little bit off as well. let's adjust that. And since this room is procedurally generated, it's really easy for us to do that. We can just first select this room and go to the details panel on the right, scroll down. You can see inside of it, there's this array that says rooms. Click this drop down inside of it, and inside of this index 0, so we can control its length, its width, and its height. So I'm going to first start with height. Instead of 9, I'm going to use a number of 7. And now the height of my room makes much more sense. And next thing that I'm going to adjust is this demo display. So I'm going to select this demo display. And same as our room, we can adjust its width, its depth, and height. So I'm going to leave this height at default, but I'm going to increase the width a little bit. So something like 6.5. And I'm going to adjust this depth a little bit. I don't want this part to come out this far. So instead of 5, I'm going to try with a value of 3. Or maybe 3.5. And I'm going to increase my height a little bit, maybe 4.2. Alright, something like this. These are the things that we're going to use throughout the course. One thing to look for this demo display is we can also adjust the text on the panel as well. So if you scroll down, you can see there's a row for us to adjust its title text. And we can adjust its scale. We can also change the content of this description text. So you can see here it says example paragraph line 1, but I'm going to leave them at default now. And once we put in more VFX, we're going to change the content of the text. And it's time for a challenge. So your challenge is, I'd like you to create an empty project for our Niagara VFX. And after that, I'd like you to set up the demo room for placing them. And don't forget to use third-person template as a reference for you to adjust the room's size and height. And more importantly, don't forget to keep a clean folder structure. For the amount of assets that we're going to create and use, our project will become very messy very soon. Alright, pause the video now and give this a go. Welcome back. How did that go for you? Hopefully right now you have your demo room ready. And if you select your demo room, so other than width and height, there are still plenty of other things that you could adjust. So try to have fun with these values and see what they will do to this room. So for example, when I change the value for the length in here, instead of 5, I'm going to change it to 8. And now you can see I have 8 slots. I'm going to change it back to 5. And we can also choose whether or not we want to have a roof, or we want to enclose left or right. So have fun with these values. And there's one last thing that I like to do, and that is I want to limit my frame rate. So by default, my project will try to reach 120 frames, but that's not what I need. So I'm going to go to Edit and go to Project Settings. And in here, I'm going to search Fixed Frame Rate. And I'm going to take it and I'm going to set my fixed frame rate to 50 frames. I think this is more than enough for this project. Note that this is completely optional. If you are confident at your GPU, you don't need to set this. I'm just trying to save some performance for all those particle effects that we're going to create. Alright, now if I go to this show FPS, now my frame rate of this project will be clamped to 50 frames, and that's perfect. In this lecture, we created a blank VFX project, and we also imported a demo room for us to place VFX that we're going to create. Great job! I'll see you in the next lecture. In this section, we're going to go over all the basic stuff about Niagara that you must know in order for you to create VFX by creating the standalone effects, flamethrower. We're first going to cover the different emitter stages inside of Niagara. Then we'll start with using the sprite renderer and start to getting more familiar with all these different modules that we can use. Then we're going to look at how we can create a custom VFX material so that we can apply our own textures to the VFX. After that, we're going to go over the sub-UV animation for sprite renderer and create this flamethrower. Then we'll go through how to use the mesh renderer inside of Niagara and how to make our custom meshes from Blender so that we can use it for our future VFX. Besides that, knowing how to use the ribbon renderer is also essential for us to create VFX we like. And more than that, we're going to cover some of the basic coding principles in Blueprint and use that blueprint to help us to create textures directly inside of Unreal. Then we're going to use this tool to help us create different types of noise textures so that we can use them to help us achieve different kinds of variations for our VFX. There's a lot of cool stuff in this section. Let's dive right in. Welcome! In the last lecture, we successfully set up this demo room for us to place our VFX that we're going to create. Now, before we proceed, there are a few settings that I'd like to change. So first, you can see the exposure of my scene is way too high, it's way too bright. I like to lower it a little bit, and I'd also like to disable this auto exposure. So I'm going to go to this visual effects, and I'm going to drag out this post-process volume. The first thing that I'm going to do, I'm going to search infinite extent, and I'm going to tick this. So now this post-process volume will affect my entire level. And next thing, I'm going to search auto, and you can see I have this exposure here. I'm going to tick this metering mode, and I'm going to change this from auto exposure to manual. Now my scene becomes completely black, and I'm going to tick this exposure compensation, and I'm going to change this to 12. And now you can see I have a working exposure for my level now. And the next thing that I'd like to adjust is the height of my demo display. So I'm going to left mouse button click it, and I'm going to increase its width a little bit, maybe to 7. And I'm going to increase its height a little bit, maybe to 4.5. Alright, something like this. Now let's start to create some particles. Before we actually use Niagara to generate any particles, let's talk about its structure a little bit. So take this VFX for example. In Niagara terms, this is called a Niagara system. A Niagara system is simply an emitter container that we can place or spawn in the world. Note that the system itself, it doesn't emit any particles. The things that are actually spawning particles are Niagara emitters. And a system can have as many emitters as we want. And oftentimes, for creating a VFX, we'll need different Niagara emitters to work together. And what a Niagara emitter is doing is simple. It simply emits and controls particles. So let's create our first Niagara emitter. Go back to my level, go inside of my content browser. I'm going to create a new folder. I'm going to call this one Niagara. And double click to open it. I'm going to create another folder. And this folder, I'm going to call it Niagara Basic. So all the VFX that we're going to create in this level will go inside of this folder. Remember, having a clean folder structure is extremely important as we will be creating a lot of VFX and we'll need a lot of assets. And double click to open this folder. I'm going to create another one. I'm going to name this to 01 first emitter. And double click to open it. We can just right mouse button click our content browser and go to FX. And you can see there are a lot of things related to Niagara that we can select. We're not going to worry about these for now. Now, I'm simply going to create a Niagara emitter. And once I click that, you can see a window pops out. And there are 3 options that we can choose. I'm not going to use the first one and the second one. Instead, I'm going to use the third one. So the third one will allow us to create an empty emitter with no modules or renderers. And this is perfect. We're going to start from scratch. And I'm going to click this finish. Now you can see a Niagara emitter has been created for me. And I'm going to rename this to NE_first emitter. So NE is short for Niagara emitter. Same as our clean folder structure, having a consistent naming convention is extremely important as well. Now double click to open this first emitter. And I'm going to maximize this window. And you can see here I am inside of this Niagara editor. On the left, this is the preview window, same as our material editor. So we can rotate our viewport by holding down our left mouse button. We can pan it by holding our middle mouse button. And inside of the center, this is our Niagara emitter. And you can see it's pretty empty. Now, what can we do with this? To answer that question, we need to first discuss all these different stages in Niagara. So in the Niagara emitter, By default, everything gets run from top down. So it starts from the top and it runs down to the bottom. And you can see there are many things in here. There's emitter summary, emitter spawn, update, and particle spawn update, and render. We're going to leave out all those upper parts and we're going to only focus on this render. No matter what kind of VFX that you want to create, this is the first thing that you need to set. So you need to have the correct renderer. So let's talk about this renderer a little bit. For all those VFX that we are going to create, we're mostly going to be dealing with these three renderers. They are sprite renderer, mesh renderer, and ribbon renderer. We're going to slowly introduce the other two renderers as we create more VFX. For now, I just want to focus on this sprite renderer. Or more specifically, when should we use this renderer instead of the other two? Well, to understand it, we first need to know what is a sprite. So a sprite is simply a 2D camera-facing plane. So no matter what we do, this plane will be always facing our camera. And by using this technique, it can help us to achieve many different types of VFX. So go back to my editor. I'm going to left mouse button click this render, and we can click this add button to add a new renderer to this group. So left mouse button click, and I'm gonna select this sprite renderer. And you can see after I click it, I get a new window. And here it says sprite renderer, and these are all the different settings that we can set. They might look quite intimidating at the beginning, but don't worry. As we create more and more VFX, you're going to understand how to tweak all these different settings. So the first one is this material slot. You already know that a material plays a huge role in the VFX. So by default, when you choose sprite renderer, you'll be using this default sprite material. And later, we'll be creating our own materials. And it's time for a challenge. So a challenge is, I'd like you to create an empty Niagara emitter, and after that, I want you to assign the sprite renderer to the render stage. And most importantly, get comfortable with our Niagara editor, as we will be spending a lot of time in this interface. So try to move through it, try to rotate the viewport a little bit. And don't worry about all those different settings, all those different panels inside of the viewport. You'll know how to use them very soon. Pause the video now and give this a go. Welcome back. Hopefully that was easy enough for you to do. All we've done so far is we've only assigned a sprite renderer to this emitter, and we still cannot see any particles, and nor can we place this emitter inside of our level. You can see when I try to put this emitter in our level, it's not allowing me to. We're going to be dealing with all of this in the next lecture. In this lecture, we talked about the relationship between Niagara system and a Niagara emitter, and we also went through what is a sprite. Great job! This is a great beginning. I'll see you in the next lecture. Welcome! In the last lecture, we went through the basic structure of Niagara. And more specifically, we talked about the relationship between a Niagara system and a Niagara emitter. We know that now a Niagara system is simply a container for all those Niagara emitters we need. And we also went through what is a sprite. This is what we have achieved so far. So far, we've only added a sprite renderer to this render stage, and we still cannot see any particles in our viewport. So in order to add particles, we'll need to understand all these different stages. Up until this point, I'm sure you already understand what this render stage is doing. And we still haven't covered all these different other stages. So we have properties at the top and emitter summary at the second. We're going to leave out these two rows for now. And instead, we're going to focus on these four rows. So there are emitter spawn, emitter update, particle spawn, and particle update. This may seem like a lot, but it's actually not. They can all be categorized into two types. So there are emitter stage and particle stage. And more than that, we can summarize them into two words. So there are spawn and update. If you are still finding these two words confusing, well, let's swap them out with Unreal's terms. So spawn is like begin play, and update is like event tick. What's the most important property about begin play and tick? Well, it's about how often will the code be run once we put something after them. So if we put some code after begin play, all the code there will only be run once. And if we put any code after event tick, they will be run every frame. And that's the most important property about them. And same thing goes for spawn and update. Understanding this is crucial for us to place any modules inside of our emitter, because we will always need to understand how often will the module be run. Now, after understanding spawn and update, let's look at all of these different stages. We'll begin with emitter spawn. So this is emitter's begin play, and in this stage, we rarely do anything in it. There will be times that we need to set some certain attributes in here, but not very often that we need to put any modules under this stage. And next thing would be this emitter update. Well, this is emitter's tick. There are quite a lot of things that we can put under this stage, and the most important thing about an emitter is its emitting particles. So in this stage, the most important thing that we need to specify is the number of particles this emitter needs to spawn. And depending on the module that we give to this stage, all the particles will be spawned for us. And after that, all the things will be passed down to particle spawn. So this is particles begin play. So in this stage, we have control over each of the particle that is spawned by this emitter. Think about that. What are the properties that we want to set when a particle is first spawned in the world? Well, there are quite some things that we need to do. So for example, we might want to set its initial size, location, or maybe even color. And the most important one, we might want to set its lifetime. So how long will this particle stay in our world before it disappears? And after this stage, all the information will be passed down to particle update. So to particles tick. After knowing the initial size, location, even lifetime for the particle, what do we want to do in this stage? Well, in this stage, we want to control its movement. So how does the particle move? Its scaling. Do you want it to become larger and larger, or smaller and smaller? Or even fading. Oftentimes, we want to fade a particle out instead of just make it disappear. So these are all the things that we can set in these different stages. And now let's look at what are the modules that we can use to make all of this happen. So go back to my editor. We're gonna start with this emitter spawn. Since we rarely put anything under it, I'm gonna leave it at default, empty, and I'm gonna continue with this emitter update. We can click this add button to add module to this stage. So after I click it, you can see it already has 3 suggested modules that I can add. So the ones that we use very often are spawn burst instantaneous and spawn rate. Now I'm just gonna use this spawn burst instantaneous. So the particles will be spawned all at once. After I add this module to this stage, you can see I have some warning here. And the title here, it says the module has unmet dependencies. So oftentimes when we add modules to our emitter, in order for a module to work properly, it needs to have another module as a dependency module. And you can see on the right, we have the button says fix issue. And by clicking it, we will be adding a new dependency module emitter state. So let's do that. After I click fix issue, you can see a new module has been added to our emitter, and it's called emitter state. And behind it, there's a word that says system. So after I click the module, you can see in this module, the most important thing that we can control is its life cycle. So instead of system, I'm gonna set it to self. So this means this emitter will have control over its own life cycle. In other words, how often do we want it to loop? And right now, its loop behavior is set to be infinite. All right, that's perfect. And you can see in our viewport, we can see our particle now. This may seem like a sphere, but it's actually not. If I go to my sprite renderer and I click this button to reset to default. Now you can see this is simply just a plane, and by using the material default sprite. So I'm gonna type default sprite. And after selecting this material, I have my particle back. This material is simply a white dot. And because the plane is always facing us, this will feel like it's a sphere. But it's simply just a white dot. Alright, I'm gonna go back to this spawn burst instantaneous. Now you can see its spawn count is set to be 1, so we can see only 1 particle. And this is enough. Alright, those are all the things that we need to do inside of emitter update. After specifying the number of particles to spawn, the next thing that we need to set is particle spawn. So how large do we want the particle to be? How long do we want it to live? Go back to my editor. I'm gonna click this Add button to add a new module to this group. You can see there are already a lot of suggested modules, but I'm not gonna use any one of them. Instead, I'm gonna type initialize particles, and you can see it's right there. After selecting it, we get a new panel, and there are quite a lot of things that we can adjust. So by default, we can see all the things that this module can control, and if you think this is too much, we can isolate each one of these by clicking the buttons here. So first, I'm gonna select this point, and in here, you can see that we can control this particle's lifetime. We can set its initial color, its position offset. I'm gonna leave all of this at default now, and let's move on. Next thing that we can set is properties related to sprite. So after clicking this button, you can see we can set the sprite size. Currently is set to be unset, and if I click this drop down, I can choose whatever I want in here. So by setting the sprite size, we are setting the size of the plane. So I'm gonna say it to be uniform, and instead of 10 units, I'm gonna say it to be 50. Alright, something like this. So if you are using sprite renderer, you can control the size in here. But if you are using the other two renderers, you'll need to do the things inside of these two buttons. We are not going to go into them right now. Alright, that's the particle spawn stage done. After this stage, everything will be passed down to particle update. So in there, we can control its movement, scaling, and fading. Let's see what modules we can add. So I'm gonna click this Add button to add a new module. And the first module that I'm gonna add is called Particle State. So what this module is doing is simple. It simply kills the particle when lifetime has elapsed. So when the particle reaches the end of its lifetime, this module will kill the particle for us. So this is something that we need to do in tick in particles update. Alright, the next module that I'm gonna add is called Scale Color. So as the name suggests, this module will allow us to control how the RGB and the alpha will change throughout the particle's lifetime. Right now you can see everything is set to be default, everything is at 1. So for this scale alpha, instead of 1, I'm gonna click this arrow here. So this can allow us to perform some math calculation on this number. And you can see it already has different suggested modules for us to choose. Now I'm simply gonna choose this float from curve. And after selecting it, you can see now our particle begins to fade. And if you look at this curve, in here, this curve index, it says normalize the age. So this means no matter how long we set the particle's lifetime to be, in here you will be remapped to between 0 and 1, and this is extremely useful for us to set certain properties. So when the value is 0, so that means when the particle is first born, it will have 1 for its alpha, and when it reaches the end of its lifetime, its value will reach 0, and the particle will disappear. And by using this curve, we can slowly fade out this particle. And that's the thing that we can do inside of particle update. And these are all the things that we can control. Alright, after setting all of those different stages, after using all those different modules, let's place our particle in our level. So go back to my editor. After finishing up all these different setup for this emitter, I'm gonna hit apply to apply all the changes that we've made. And I'm gonna minimize this window. Now to place a particle inside of our level, instead of using a Niagara emitter, we need to use a Niagara system. And to create a Niagara system from an emitter is fairly simple. We can just right mouse button click and select Create Niagara System. And now we have our Niagara system ready. So I'm going to change this to NS_first system. So NS is short for Niagara system. And we can place this Niagara system directly into our world. And there you go, we have our first particle. If you think this icon here is annoying, you can press G on your keyboard to hide it. And press G again to show the icon. After having our first particle ready, I'm going to change some text on the panel. So I'm going to select this BP demo display and scroll down. So the title here, I'm going to change it to first emitter. And for the description text, I'm gonna first click this remove all elements, and I'm gonna add one more, and I'm gonna type in only Niagara system can be placed in the level, and I'm gonna change its font size to something like 30 or maybe 20. Alright, something like this. And it's time for a challenge. So your challenge is, I'd like you to spawn a particle that has a size of 50 and a lifetime of 2 seconds. Hopefully you still remember at which stage you can set these properties. And after that, I want you to slowly fade out this particle. And last thing, I want you to place the particle in your level. Pause the video now and give this a go. Welcome back. How did that go for you? Hopefully that wasn't too hard for you to do. Now you can see on my panel I added 3 lines of text. You can do so by left mouse button, click it, and go to this description text by clicking this add element button. And you can add as many paragraphs as you want. And also you can control the spacing of the different lines. I've already set mine to 3. You can increase the spacing or decrease the spacing. I think 3 is reasonable in here. You can see that in here, the content still isn't completed, and that will be our reflection task today. So your task is, I'd like you to write down what you still remember about emitter update, particle spawn, and particle update. Or how often will the modules be run once we put in this stage. Understanding all these different stages is the key for us to achieve the things we want next. And another good reason to do this is, the official documentation of Niagara still isn't too good, so why don't we create a documentation of our own? And in the future, if we need to revisit some of the parts, we can walk through this gallery that we've created ourselves. And this can surely help you to review what you've learned. Alright, consider this as a homework, and we'll compare our answers in the next lecture. I'll see you in the next lecture. Welcome! In the last lecture, we created this simple particle and we placed it in our level. And I also left you a reflection task to do, and now let's compare our answers. So I'm gonna first disable this real time. So by doing this, anything that moves inside of our level will stop moving. These are the answers that I wrote for these different stages. And if your answer varies from mine, don't worry. As long as it's not way off, your own understanding will always be much more valuable. And if you think the questions here are way too easy, you already know the answers of them, feel free to write down your own things on the panel related to this VFX that you've just made. So far, we've only created one particle and really doesn't look interesting. This is simply a simple sprite renderer, and the particle itself, it really doesn't move at all. So in this lecture, let's create a much more interesting one. I'm gonna first enable this real time, and I'm gonna go back to my Niagara basic folder. In here, I'm gonna create a second folder. So I'm gonna call this O2 simple moving sprite, and double click to open this folder. Unlike the last lecture, instead of starting with a Niagara emitter, this time I want to start with the Niagara system. So I'm gonna right mouse button click, and you can see in here, there's already a Niagara system that we can select. So after selecting it, we have these many options in here. Now I'm going to choose this new system from selected emitter, and this could allow us to select all those existing emitters, and depending on the emitter template that we select, we could go from there. So I'm going to click next, and in here under this templates, you can see there are already many existing templates for us to choose. Very soon you're going to understand what all of these templates are doing. Now I'm going to select this simple sprite burst to begin with. So after selecting it, I'm going to click this add button, and now you can see here it says emitters to add. So we can add multiple emitters to start. But for now, I just want to begin with this simple sprite burst and click finish. Now I'm going to name this Niagara system to be ns_simple moving sprite, and double click to open it. Now you can see the interface here is pretty similar as our Niagara emitter, but we have this one more blue panel added to this system. So in here, we can control some of the basic attributes of this Niagara system. We'll come back to this very soon. Right now, let's just look at this emitter. So hopefully you'll find this pretty familiar, because this is very similar as the first emitter that we just created ourselves. So you can see under this emitter update, here it says emitter state, and the lifecycle mode is set to be self. This is the same as the emitter that we created. and the loop behavior is set to be once. I'm going to leave all of this at default now. And here we have a spawn burst instantaneous, and the spawn count is set to be 1. So this is the same as we did. And under this particle spawn, we have this module initialize particle. So the lifetime of this particle has already been set to be 2 seconds, and the sprite size has already been set to 50 units. And under this particle update, we have particle state and scale color. So pretty much this is everything that we've done so far, except Unreal already has it prepared for us. So it can really save us a lot of time in doing this for every new Niagara system that we create. And you can see there's one more module for this Niagara emitter, and it's called self forces and velocity. Very soon we're going to need this module, but for now I just want this particle to move. So I'm going to go to this particle spawn stage, and I'm going to click this add a new module button. And here you can see there's already a module suggested, and it's called add velocity. I'm going to select it, and right away you can see my particle begins to move. So we can set the attributes for this module at velocity. So by default, this velocity mode is set to be linear, and the velocity is set to be 50 units on the z-axis. We can even scale this velocity speed. So if I increase this number to 2, the particle will move faster. So I think a number of 1 is reasonable in here. And now, instead of just moving one particle, I like to move multiple particles. So I'm going to increase its spawn count. So instead of 1, I'm going to try a number of 10. And you can see our particle becomes brighter, but we still can only see 1. And that's because all the 10 particles are spawned together, so they are moved together. This add velocity module is under the particle spawn stage, so this will be only called once. So spawn burst instantaneous isn't really ideal in here, so I'm going to delete this module, and instead I'm going to use the module spawn rate. And after selecting this module, I'm gonna change the number from 0 to 10. Now you can see we are moving all those 10 particles, and because they are spawned under a certain spawn rate, we can notice a difference in here. Right now the particles are too large, and if I want to decrease their size, which stage should I go into? Alright, I hope you still remember we can do that inside of this initialized particle. So you can tweak the properties directly in here, or if you don't want these 2 extra panels, you can go to this sprite renderer and change the size from there. So instead of 50, I'm going to change it to 25. And I'm also going to tweak my velocity scale a little bit. So instead of 1, I'm going to change the value to be 3. And now you can see I'm moving all those particles along the z-axis. Alright, this seems good enough. Now I'm going to place it into my level. So go back to my level. First, I'm going to duplicate this demo display. So after selecting it, I'm going to hold down Alt on my keyboard and drag it out. So now I have a new demo display. And first, I'm going to delete all of this description text. So I'm going to click this remove all elements button. And I'm going to change its title to be simple moving sprite. And I'm going to drag in my Niagara system. And I'm going to place it in the level. And after doing that, you'll notice we have an issue. All the particles are only spawned once. And after that, we can no longer see particles in our level. Well, that's because we need to change its looping behavior. So double click to open my Niagara system. Inside of this emitter state, you can see currently the lifecycle mode is set to be self and the loop behavior is set to be once. And if this is something that you want to constantly see in your level, you will want to change this to be infinite. And now if you go back to your level, you can see the particles are being updated constantly. And note that this is not the only way to have a system that loops forever. So besides setting the loop behavior to be infinite, you can also change its life cycle mode from self to system. And this will also result in this emitter to loop infinitely. Well, that's because once you do that, the Niagara system will take over this emitter's life cycle, and by default, a Niagara system is set to be looping forever. So if you go to this system update, you can see the loop behavior here is set to be infinite, and the loop duration is set to be 5 seconds. So this is another way to loop your particles. Now I'm going to decrease the size of my sprite a little bit, so maybe something like 15. And I'm going to decrease its spawn rate a little bit, maybe to 5. Alright, something like this. And it's time for your challenge today. So your challenge is, I'd like you to create a Niagara system using simple sprite burst. Hopefully, you'll find all these pre-existing modules inside of this emitter template familiar, since we created all of those in the last lecture. And after that, I'd like you to spawn multiple particles and move them using at velocity. And finally, I'd like you to place your system into the level. Pause the video now and give this a go, or refer back to the video if you need help. Welcome back. How did that go for you? Hopefully, you had no issues in moving your particles. Same as our last lecture, I have 2 questions for you as your reflection task today. So think about answers for these 2 questions. 1. What is the difference between spawn burst and spawn rate? And another one, how often will the module at velocity be run? Again, if you think these 2 questions are way too easy, feel free to write down the things that you think are more important. And we'll compare our answers in the next lecture. I'll see you in the next lecture. Welcome! In the last lecture, we successfully created this simple moving sprite. And I also left you 2 questions for you to think. So now I'm going to disable this real time, and I'm going to pause here for a few seconds. So try to compare your answers with the answers that I wrote, and don't worry if your answers vary from mine. Remember, your understanding will always be much more valuable. Alright, so in last lecture, we covered the spawn burst and spawn rate, and we also used the module at velocity. And later, for the VFX that we are going to create, we are going to heavily need these modules. So far, we can only spawn our particles at a fixed location. And generally, this is not something we want when we are creating other VFX. So in this lecture, let's look at what we can do about it. First, I'm going to go back to my Niagara basic folder, and I'm going to create another one. So for this one, I'm going to call it O3 shape location and double click to open it. Same as our previous lectures, in here we need to create a Niagara system and we need to place it in our level in order for us to see it. And there will be your mini challenge today. So your challenge is, I'd like you to create a Niagara system using simple sprite burst. And after that, I want you to allow the particles to loop forever. Hopefully, you still remember where you can set those things and where you can find this emitter template for us to use. And lastly, place your system onto a new demo display. Pause the video now and give this a go. Welcome back. Hopefully, that wasn't too hard for you to do. So now I'm going to duplicate this demo display first. We're going to hold down O on my keyboard and drag it out. So for this one, I'm going to change its name from simple moving sprite to shape location. And after that, I'm going to delete all these description tags. So click this icon to delete. And I'm going to create another Niagara system. So I'm going to select Niagara system and select this new system from selected emitters and click next. After that, I'm going to scroll down and I'm going to select this simple sprite burst and click finish. So for this one, I'm going to call it NS shape location and double click to open it. So first things first, I like to set this particle to loop forever. So I'm going to go inside of this emitter state. I'm going to change this loop behavior from once to infinite, and the loop duration is 2 seconds. Alright, that's enough. And I'm going to also delete this spawn burst instantaneous. Instead, I like to use spawn rate, and I'm going to give it a number of maybe 100. Something like this. Alright, now we have 100 particles in here. Now, under this particle spawn, first I'm going to decrease their size. So instead of 50 here, I'm going to change it to 10. And now all of those particles are spawned at the exact same location. I like to use the same module that we used in last lecture. So I'm going to click this button here and I'm going to select this at velocity. And now you can see my particles begin to move. Now, this isn't too ideal and very rare that we want our particles to spawn at the exact same location. So to change that, there's another module that we can use under this particle spawn stage, and that will be this shape location. So you can see, since it's already used very often, we can directly select it in this suggested module section. So I'm going to click that. And right after that, you can see all my particles are being separated. So by default, when you select this shape location, the shape primitive will be set to be sphere. So all of the particles will be spawned in a sphere. So I'm gonna disable this real time here so we can pause whatever is happening inside of here, and we can change the sphere radius in here. So if currently I think the radius of this sphere is too large, I can decrease it down to maybe 50, and now I have a smaller sphere. I'm gonna disable this add velocity module for now in order for us to see it better. So now you can see all the particles are being spawned in the sphere. This is one of the most used shape location for a VFX, but that's not the only one. So if you go to this drop down here, you can change this shape from sphere to other shapes. And depending on the VFX that you want to create, oftentimes selecting the correct shape location will be an important start. And below this shape location, you can see there are some other properties that we can set. So for example, we can change this sphere surface distribution. So this will determine where those particles will be spawned on the sphere. And also we can change the transform of this sphere. I'm not going to tweak those values for now, and I'm not going to go into these different shapes for now because that will be your challenge today. So your challenge is, I'd like you to spawn your particles in various shapes. And more importantly, I'd like you to tweak the parameters for the shape you selected. So by adjusting those values of the module inputs, sometimes we can get a very interesting result. And don't worry if you find those values look intimidating. They'll become easier and easier as we use them more and more later in the course. Right now, just be comfortable with those values and with the names of those shapes. After that, I'd like you to spawn your particles in this shape. See if you can figure out which shape I use in here. And in order to achieve this result, I may have also used some other modules. And based on this picture, see if you can figure out which module might have been used. Alright, pause the video now and give this a go, or come back if you need help. Hey, welcome back. How did that go for you? Will you be able to create the shape that you desired? Now I'm gonna first enable this real time so that my particles will begin to move again. And I'm gonna go to this shape location. So instead of sphere, I'm gonna change it to torus. And now you can see my particles are being spawned in a torus. Let's see what this will look like in our level. So go back to my level. I'm gonna drag out this Niagara system and place it in my level. Also, I'm gonna enable real time for my level. And now you can see all the particles are being spawned in a torus. But this is not quite the result that I want. I want this torus to face our camera. Right now, this torus is facing up. And that's not what I want. We can fix that by going back to our Niagara system. And we can change the rotation of this torus inside of this transform section. So if this is the only section that we want to see, we can click this button in here. In this rotation mode, instead of default, I'm going to change this to axis angle. And now you can see this shape has been rotated, but instead of a value of 1 in x-axis, I'm going to change this to 0. And I'm going to give it a value of 1 in the y-axis. So now this torus will be facing our camera. So go back to my level, you can see now we have a camera facing torus. I'm going to drag it up a little bit, something like this. Alright, in order to make this look more interesting, I'm going to go back to my Niagara system and I'm going to turn on this add velocity. So now my torus begin to move. And more than that, there's another module that I like to add inside of this particle update. So you already know that using this scale color module, we can scale the alpha of the color. And since all the modules under this stage is being constantly updated, we can also scale the size of our sprite. And the name for the module is called scale sprite size. And you can see it's right there. After clicking it, by default, we'll have a curve that looks like this. So the size of our sprite will slowly increase depending on their lifetime, but this is not quite what I want. I'd like to adjust this curve. So there are two ways for us to adjust the curve inside of the Niagara editor. So first, we can directly adjust it in here. Or if you like to have a bigger viewport, you can click this icon here. So this will show this curve in the curve overview. After I click it, I can see my curve in here. And this is a much larger window for me to adjust this curve. First, I'm going to select this value. And instead of 0, I'm going to change it to 1. And now the size of my sprite will stay constant during their lifetime. And I'm going to select this key. I'm going to change its value to be 0. Now the size of my sprite will decrease. And this is a linear curve, but I don't want a linear curve. So for that, I can select both of these keys, press 1 on my keyboard. And now I can convert this curve into a more smooth one. And pressing the hotkey on our keyboard isn't the only way. You can also right mouse button click after you're selecting these two keys. So you can see 1 means auto. So we'll have a smooth curve. You can try out all these different options here, but oftentimes an auto curve is what we need. Alright, I think this looks good enough. I'm going to go back to my level, and now we have a shape location. And same as always, our lecture today will end with a reflection task. So first question, I'd like you to write down the interesting shapes that you still remember from the module shape location. There are quite a few out there, and you can just write down a few that you think are interesting or will be useful in the future. And another one, I'd like you to write down something for the shape location and modules used here on this demo display. If you created a different shape in here, write down something about that, or it can be anything else that you think are more important. And we'll compare our answers in the next lecture. Now see you in the next lecture. Welcome! In the last lecture, we combined shape location and add velocity to create a Niagara system like this. And I'm gonna pause the real time in here. So these are the answers that I wrote for the two questions that I left. Feel free to write down things that you think are important in here, as shape location is definitely something that we'll use very often in the future. Alright, after understanding the shape location, it's time we start to apply some forces to our particles during particle update in order to make our particles to look more interesting. To do that, I'm going to first duplicate this demo display. And for this one, I'm going to change its title from shape location to forces. And I'm going to delete these two sentences in here. And after that, I'm going to go back to this Niagara basic folder. I'm going to create another one. This one, I'm going to call it O4 forces. And double click to open it. I'm going to create a new Niagara system. Select from one of these existing templates, and same as usual, I'm going to use the simple sprite burst to start with. And click finish. So for this one, I'm going to call it NS forces and double click to open it. First, I'm going to change all the settings just like what we did before. So first, change this from 1 to infinite. And delete this spawn burst and use this spawn rate instead. And give it a number of 100. And I'm going to decrease the particle size from 50 to 10. And I'm going to add the shape location right away. So this time I'm going to use sphere, and a radius of 100 is enough in this case. And going down to this particle update, I'm going to click this add button. You can see there's a drop down that says forces. And once we click it, inside of here, there are tons of forces that we can choose. After selecting any one of them, the force will be applied during particle update. And depending on the VFX that you want to create, usually we'll need multiple forces in order for it to work. As you can see, there are quite a few out there, but first things first. Before I add any one of these modules, you can see in this particles update stage, there's this module called self forces and velocity. As long as your Niagara emitter needs forces, you'll need this module, no matter which stage you add the force to. So for example here, I'm going to add the module at velocity, and after that, I'm going to delete this module, and you can see my particles, they start moving. In this module, we get a warning message. Here it says the module has unmet dependencies. So for any forces to work inside of this emitter, we'll need to use this module, so forces and velocity. So I'm going to click this button, fix issue. And now my particles start to move again. So the first module related to forces that I'm going to add is one that we'll use very often. So it's this curl noise force. After selecting it, now we still cannot notice a huge difference, so I'm gonna disable this add velocity. And you can see using curl noise force is the fastest way to provide randomness to the movement of our particles. So in here, for these module inputs, we can control the noise strength and the noise frequency. So say I now increase the strength from 10 to 100. And now my particles, they have a lot more randomness. And if I also take this add velocity, I'm going to decrease this add velocity. So instead of 1, maybe 0.5. So something like this. And besides this module, there are a lot of other modules that we can add. And you can find all of them under this drop-down forces. And that will be your challenge today. So your challenge is, I'd like you to use forces in particle update stage. So same as our shape location, try to tweak the values for the force you chose and try to see what they will do to your particles. Remember, you can always apply one or multiple forces to your particles. And the most important thing here is, don't try to memorize all of them all at once. It's impossible for you to remember what each one of them will do, since there are quite a lot of them. As we use them more and more in the future, you'll find them easier to remember. For now, just try to be comfortable with them, be comfortable with the names, and be comfortable with adjusting all of those values. Alright, pause the video now and give this a go. Welcome back. How did that go for you? Hopefully you had fun in applying forces to your particles. Now I'm going to keep adding forces to my particles here. So first I'm going to disable this add velocity in order for us to see all the forces better. And the second one that I'm going to add is called drag. It simply slows down the velocity of our particles. So right now you can see the number for the drag is 1. So right after I say to 10, now my particles barely move. It seems like they're kind of floating, and they sometimes can create a very interesting result. So I'm going to lower down this value to 1. And for my curl noise force, I'm going to decrease it to maybe 500. Now I have more randomness. And another one that I think is very interesting is this vortex velocity. So what this module is doing, let me just quickly show you. Now the velocity amount is set to be 200. I'm going to increase it to 2000. Now you can see my particles are rotating around the z-axis. So right now the value for the vortex axis is 1 for the z-axis. And if I change the value to be 1 for the x-axis, now you can see my particles are rotating around the x-axis. And with the combination of curl noise force and drag, we can get a very interesting result. So I'm going to increase the drag maybe to 10. And I'm going to also add the module scale sprite size. And instead of using this curve, I'd like to decrease the size of my particles throughout their lifetime. So I can select the keys and I can change the value from 0 to 1 and select this one, change it from 1 to 0. Yes, I can do all of that and press 1 to convert the curve into a more smooth one. Or I can just use one of the templates in here. So you can see, by default, there are already a lot of curves being set for us. All we need to do is click it. So the curve that I'm going for is this one. After clicking it, now I have my curve. If this is happening that you cannot see the two keys of yours, you can just click this viewport and press F on your keyboard. And now you can see this is exactly the curve that I want. And there are a lot of other preset curves in here, and this can save us a lot of time in manually adjusting those curves. Alright, something like this. I'm pretty happy with this result. So go back to my level. I'm going to drag out my Niagara system forces and drag it up a little bit. I'm going to turn on my real time. And I think instead of rotating around the x-axis, I want my particles to rotate around the y-axis. So I'm going to go back to my vortex velocity and set the x value to be 0 and set the y value to be 1. Alright, something like this. And I'm going to decrease the drag a little bit, increase my curl noise force from 500 to 1000, just to provide it more randomness. Alright, something like this. Now go back to my level. Yeah, I'm pretty happy with the result in here. And our lecture today will end with 2 questions. So first one, at which stage we want to apply the forces to our particles. And second one, what are the forces that you use in here. So you may have used a lot of different forces. Try to see if you still remember what the ones that you use. I'll see you in the next lecture. Welcome! In the last lecture, we applied multiple forces to our particles, and as a result of that, we get particles like this. The forces that are used here to achieve this are curl noise force, drag, and vortex velocity. Depending on your result, depending on the forces that you chose, you might have something completely different. But that's a good thing. Now, after understanding the sprite renderer, the shape location, the forces, the different particle stages, it's time we actually combine everything we've learned with GPU sprites. So, you already know that a sprite is simply just a camera-facing plane, and the reason why we can see spheres on our screen is because of the material that we use. And so far, we've only used what's called CPU sprites. First things first, all the particles, they are spawned on CPU. So the one on the left, this is CPU sprites, and the one on the right, this is GPU sprites. So the only difference between the two is CPU sprites are processed entirely on CPU, while GPU sprites are processed entirely on GPU. And one of the many good things for using GPU sprites is with our GPU involved, we can process thousands more particles than CPU without causing too much of a performance hit. Now you might be wondering, then does this mean we should use GPU sprites all the time? Well, that's not the case because certain modules are only available to CPU. If you choose a module that's not supported on either CPU or GPU, Niagara would usually give you a warning about it, so you'll see what they are when we encounter them. And with the GPU sprites and all those forces combined together, there are already a lot of interesting variations that we can create. So first, let's see how we can enable this GPU sprites. Go back to my level, I'm gonna duplicate this demo display again. And I'm going to call this GPU sprites. And I'm going to delete these sentences. So go back to my Niagara basic folder. I'm going to create another one. I'm going to call this 05 GPU sprites. And double click to open it. Same as usual. Create a Niagara system. Choose this simple sprite burst as our emitter. And name this to GPU sprites and double click to open it. So first, in order to use the GPU sprites, we can set it inside of these properties. So after clicking it, you can see the sim target here is set to be CPU sim. And in the dropdown here, we can change it to GPU compute sim. After doing that, you can see we get a warning message, and here it says missing fixed bounds. So after changing the sim target to GPU compute sim, we also need to change this calculate bounds mode. So instead of dynamic, we need to change it to fixed. And now you can see that warning message is gone. And the reason for that is, after we set the particles to be processed on GPU, our CPU won't know the size of our particles. So it's important that we set it to be fixed bounds in order for everything to work properly. And if you click this drop down here, you can see this is simply just some hard-coded values for the bounds of our particles. Alright, I'm gonna keep changing some of the settings for this emitter. So inside of this emitter state, I'm going to change it to infinite. And inside of this spawn burst instantaneous, now I'm going to change this number to be 3500. And now we have a lot more particles in here. And I'm also going to use the module spawn rate. And I'm going to change the number to 1000. So we'll be having 1000 particles that's spawned by this module and another 3000 more spawned by this module. And this will completely kill our performance if this is a CPU sim. But luckily, we have GPU sim. Now go to this initialize particle. For its lifetime, instead of direct set, I'm going to set it to be random. So I want some of my particles to live a lifetime of 3 seconds and some of them to have a lifetime of 5 seconds. Alright, something like that. And for their size, I'm going to set it to be 1.5. And after that, I'm going to add another module. Since all the particles cluster together, I'm going to use shape location. And now you can see I have a lot of particles in here. So for the sphere radius, instead of 100, I'm going to decrease it to 15. And now they will all be spawned from this small sphere. Alright, that's everything that I want to set for this stage. Now moving on to this particle update. First thing first, I'm going to use the module scale sprite size. And I'm going to use one of the preset curve. So I like to use this one. Now their size will decrease throughout their lifetime, and I'm going to keep adding other forces. So next one, I'm going to add this curl noise force, and now things start to get interesting. So I'm going to change the noise strength from 10 to 125. There are no really specific reasons for me to use specific values, so feel free to use your own values. And for the noise frequency, instead of 50, I'm going to decrease it to maybe 25. Alright, something like this. And besides that, I'm also going to take this pen noise field and give it a value of 1 in the x-axis. This can provide us some more interesting variations. And I like to add another force, another module. So that module is called point attraction force. And I'm going to change this attraction strength from 1 to maybe 4, just to provide it more variations. And what this module is doing is simply attracting our particles. And you can see this point to attract is the particle's position. And this attractor position is this simulation position. So in other words, where our emitter is. And I'm going to also add drag, just to make it look more interesting. And now you can see I already have some interesting particles moving in here. And the last thing that I want to do is I like to set the colors for my particles. And there are 2 spots for us to do that. So first, we can set its initial color inside of this initialized particle module. So we can directly change its color in here. But remember, this will only be run once. And after setting the color, we cannot change it inside of this stage. And inside of this particle update, there's a more powerful module that we can use. So I'm going to click this app button and I'm going to add the module color. So note that we have 2 modules related to color here. One is this color, one is this scale color. So you can only have one of these 2. So you either have scale color or you have color. Whichever module is under will override the module above. So by having the color module below, we no longer have the scale color module. So I'm going to delete it. And this module will be constantly updating, meaning we can change the particle's color during their lifetime. And to do that, we simply need to change this static input to a dynamic one. By default, when we add a module to these stages, we'll have some static inputs. And by clicking this dropdown here, we can change this static input to a dynamic input. If you click this dropdown here, you can see all the available dynamic inputs that we can use. And usually all the suggested ones are enough for the things that we want to do. So I'm going to select this color from curve. And you can see we get this gradient map. And there are 4 pins by default. So the ones that above, these 2, we can use them to control the color. And the ones below, these are the pins that related to opacity. In 5.1, when your mouse hovers over it, it doesn't tell you what this is doing. But in other versions of the engine, it will actually say what this pin is doing. So this pin means an opacity of 1. And this pin means an opacity of 0. And this will be the color when the opacity is 1. So let's try to change that. I'm going to double click to open this pin, and you can see we get a color picker. So the color that I like to begin with will be something bluish, and click OK. Now you can see our particles, they have color. And you can see we also have this fade out effect. And that's because as our particle lives in the world, its opacity is going to slowly decrease from 1 to 0, and its color is going to slowly transition from this into this. And if we want it to change to different colors, we can just simply use left mouse button click to add a pin. Now I'm going to change the color in here to something maybe greenish. Alright, something like this, and you can see now my particles color changing from blue to green. And we can keep adding more pins in here, so I'm gonna add another one here. Maybe this one will be something yellowish. Alright, something like this, and I like to add another one here, so maybe this one, something red. And you can see in this stage, we can barely see any red, and that's because to this point, the opacity of our particle is fairly low, so we cannot see much of the red, but we can change that. We can add another pin in here for controlling the opacity. And right now, you can see the value is set to be 1. And after doing that, our opacity will only start to decrease at this point. Now we can see more red. All right, I think I'm happy with the result in here. I'm gonna go back to my level, and I'm gonna drag in this Niagara system and place it in my level. And now we have some fairly interesting particles. And it's time for a challenge. So a challenge is simple. I'd like you to try creating something similar using GPU sprites. And these are the modules that are used inside of this single emitter. So in order to use GPU sprites, you can go inside of this properties panel and change it from there. And remember to set it to be fixed bounds. And after that, it's simply just applying forces, tweaking the values. So feel free to take a reference of this and try to create your own variation. And don't worry if your results vary from mine. Have fun with those values and try to experiment more. Alright, pause the video now and give this a go. Welcome back. How's that? Hopefully you got yourself some fairly interesting results. And now there's one more thing that I like to set for the colors of my particles. So double click to open my system. Now I like to increase the brightness of it a little bit. And to do that, it's fairly simple with this gradient editor. We can just double click to open this color picker. Go to the spot where it says V. So here V means value. Instead of 1, I'm going to change it to 5. Now you can see the brightness of the blue has increased significantly. And I'm going to also be doing the same thing for the green. So instead of 1, maybe 3. And for the yellow, I'm going to change it to maybe 2. And for the red, maybe 3. I'm just picking the values randomly, so feel free to experiment with your own values. And now I think this looks fancier than what I had before. So after using the GPU sprites and combined it with multiple forces, this is what we can come up with. And now if you go inside of this Niagara system, this new system from selected emitters, and if you look at all of these templates again, these are just a bunch of pre-built emitters that contain some preset modules. Take this fountain emitter for example. So in order for our particles to move like a fountain, so maybe it needs a very specific shape location, it needs some very specific forces module, and same thing goes for this hanging particle, this simple looping particle. So feel free to dig in to see what these templates could do. And now, with the knowledge of what we have so far, and with all those existing templates, there are already a lot of VFX that we can create. And in the next lecture, we'll see how we can do that. And our lecture today will end with a reflection task. So try to think about these 2 questions and write down your own answers. So question 1, when to use GPU sprite? And number 2, what are the forces that you use to pull this effect off? So if you have used different forces modules, feel free to write them down here or anything else that you think are important. Great job! I'll see you in the next lecture. Welcome! In the last lecture, we successfully created this VFX using different forces combined with our GPU sprites. So far, we've only been using default sprite material for the particles that we created. And there are so much more that we can create when we apply our custom materials to all of those particles. In this lecture, let's look at how we can create some custom materials. So first things first, we'll need to have some textures. And luckily for us, there are already a lot of stunning textures prepared for us. We just need to know where to get them. So the first path of texture that I'm gonna get will be from this VFX pack. You can see this is a free pack, so it's called Realistic Starter VFX Pack. Inside of it, there are a lot of VFX that's made using the old VFX system, the Cascade particle system. We are not interested in those, but with the textures this pack can provide, we can use Niagara to create something much better. So I'm gonna first add this pack to my project. And you can see by default, this pack already supports 5.1. So I'm gonna click Add to Project. Alright, after adding this VFX pack, The only folder that I'm interested in is this textures folder. So you can see inside of it, there are a lot of decent textures that we can use. So I'm going to copy out this folder and then I'm going to delete this pack. So first, I'm going to go back to my content folder. Inside of it, I'm going to create a new folder. I'm going to call this one textures. And right away, I'm going to copy out this texture folder. So I'm going to select this folder and I'm going to drag it to my own texture folder and select copy here. And after that, I'm going to go to File and click Save All. Then I'm going to rename this folder to realistic_VFX texture. And these are all the textures that we can use later. And next thing, I'm going to delete this VFX pack. So I'm going to select it and right mouse button click and choose delete and just click delete in here. Alright, now that we have the textures ready, next thing we need some materials. So I'm going to go back to my content folder. I'm going to create another one and I'm going to call this material. And double click to open it. Right mouse button click, I'm going to select this material and I'm going to keep its name a default. I will change that later. Double click to open it and this is the default interface that we'll see. So first I'm going to bring in the texture that I'm going to use later. So it'll be from this realistic VFX textures. And the texture that I like to use is this T_dandelion. So I'm going to drag it into this viewport and place it in there. Alright, which socket should we plug in order for this VFX material to work? So in order for a material for VFX to work, there are quite a few settings that we need to set. This is the default sprite material that we've been using. You can see this is simply just a white dot. And in order for this white dot to work, there are 3 settings that we need to set. So first, we need to have a correct blend mode. And second, we need to have a correct shading model. And last one, we also need to have this two-sided option ticked. Let's go over these options one by one. So here I am inside of the material editor. I'm going to click this new material and you can see in here, there are some settings that I can set. So the first thing that we're going to set is this blend mode. After I click this drop down, you can see there are plenty of options that we can choose. So for VFX material, the most commonly used blend modes are translucent and additive. But which one should we choose in here? Well, to answer that question, we first need to know what's the difference between the additive and translucent. As you can see here, I have 2 sprites. They have the exact same size and they are using the exact same material, except one of them is using the additive blend mode. Another one is using the translucent blend mode. So just by looking at them, can you tell what difference do they have? Maybe right now you are thinking, well, they don't look too different to me. And you are correct. But once I start to change their colors, things will change. So for these 2 sprites, same as above, they are using the exact same color. But you can see we get a quite different result in here. So the particle, the sprite on the left, this is using the additive blend mode. And the one on the right, this is using the translucent blend mode. When dealing with the VFX material, this is the biggest difference of these 2 blend modes. So for the additive blend mode, when dealing with colors, the black color will just render as transparent. While in this translucent blend mode, we can actually show darkening colors. And there will be times that we need to have some dark colors inside of our VFX. And if that material that we're going to apply black colors to is using this additive blend mode, then we won't be able to see any dark colors. And if our VFX only needs bright colors, we can just stick with this additive blend mode. So go back to my material editor. First, I'm going to change this blend mode from opaque to additive. So for my dandelion, I don't need any dark colors. Alright, that's the blend mode done. And next thing that we need to set is this shading model. So by default, it has been set to default lit. And most of the time, default lit is what we'll be using inside of Unreal Engine for PBR material. So for default lit, it can cast both shadow and light. But for a VFX material, we want this to be unlit. So inside of this shading model, it does not cast any shadow or light. And this is perfect for a VFX material. So I'm going to change this shading model from default lit to unlit. And you can see after that, we have access to only a few sockets. And the one that we'll be using all the time are this emissive color and opacity. Now, the socket emissive color is easy to understand. We just need to plug the color information inside of it. But why do we need this opacity socket? Let me just quickly show you. So now I'm going to plug the RGB information of this texture into this emissive color socket. And I'm going to change my preview mode to this plane. And you can see this is our dandelion. I'm sure you can notice that the result here isn't too ideal. And that's because we only want this dandelion in the middle. We don't want this background. And to get rid of that, we need to access the opacity socket. In other words, we need to understand what will be rendered as transparent and what will be rendered as opaque. To quickly show you an example, I'm going to hold down 1 on my keyboard to bring out a scalar. So this is just a single value. I'm going to first set its default value to be 1 and plug this into emissive color. And now you can see we get a white plane. So colors, they're just values, and a value of 1 will get us this white surface. And I'm going to change the value to be 0. And we cannot see anything for now. So theoretically, we should be seeing a black surface, but why can't we see anything at this moment? Think about that. What's the reason for it? Alright, hopefully you still remember. Currently, we are under this additive blend mode, and inside of this mode, any black color will just be rendered as transparent. So in order for us to see the black, I'm going to change that from additive to translucent. And now you can see, we can see a black surface. That's the color for a value of 1 and a value of 0. And once I plug a value of 1 into the opacity, you can see we can get a totally opaque surface. And when I change the value from 1 to 0, you can see we get a completely transparent object. A value of 0 means transparent and a value of 1 means opaque. And going back to our texture, so we need to have some kind of pattern that only has white in the middle and has black for the background. So let's double check this texture to see in which channel we can get such a pattern. So I'm going to click this magnifying glass and it will take me to where this texture is located. Double click to open it. So you can see for this texture, it has alpha channel, and usually inside of the alpha channel, it has the value we need. So I'm going to first mute the 3 channels first. So I'm going to disable RGB channel, and you can see for this alpha channel, we have the exact values we need. So only white parts for this dandelion and black for this background. Using white values to show certain parts, using black values to hide certain parts, that is also known as a mask. And this is the mask we need. Go back to my material, I'm going to plug this alpha into opacity. And now we have our dandelion. But we still need one more node to set up this VFX material. So when we use this material instead of VFX, oftentimes we want to alter its color. We will want to alter its opacity. Sometimes maybe we want to scale its alpha to slowly fade out this particle. And for that, we'll need to have another node. So it's called particle color. The 2 pins that we need are this RGB and this alpha. We can combine the RGB information of these 2 nodes together by using a multiply node. So you can hold down M on your keyboard to bring out a multiply node. I'm going to plug this RGB into A and plug this RGB into B and plug the output into emissive color. Now, whatever changes we make to colors inside of our Niagara system will affect this material. And for the alpha channel, we can use the same method to combine them together. So I'm going to hold down M on my keyboard and plug the alpha into A, plug this alpha into B, and plug this into opacity. And that's it. This is the most basic setup for a VFX material. And it's time for a challenge. So your challenge is, I'd like you to import the texture pack from this realistic starter VFX. Same as I did, you can just copy the texture pack from it. And after that, you can just delete this pack. And after getting hold of the texture that you need, create a material for our VFX. Be careful with all the settings and feel free to refer back to the video if you need help. Pause the video now and give this a go. Welcome back. How did that go for you? Hopefully that was easy enough for you to do. After creating this material, I'm going to rename it. So same as our folder structure, having a fixed naming convention for our assets is very important in here. So I'm going to call this material m_single texture master and _ additive. So this will be the master material for all the future VFX that we're going to create. If that VFX only needs a single texture, Then this is the material that I will be using. So instead of creating material after material, I'm just going to create material instance. So double click to open this material. I'm going to convert this texture sample node into a texture parameter. And I'm going to call this parameter main texture. And I'm going to hit apply, and I'm going to right mouse button click to create a material instance. So for this material instance, I'm going to call it mi_dandelion_additive. And the last thing that I want to do is I'm going to click this node and I'm going to tick this two-sided option. So if we are only going to be using this material for a sprite renderer, we might not need to tick this. But we might also want to use this on a custom static mesh. And there will be times that we want to look at the mesh from the back. So if we don't tick this, we just won't be able to see anything from the back of the mesh. Alright, I'm going to click apply. And that's the basic setup for the material done. And in the next lecture, we'll look at how to set up our Niagara system. In this lecture, we went through the materials blend mode, and we also talked about the shading model. And we also covered the importance of the opacity socket for a VFX material. Well done. I'll see you in the next lecture. Welcome. In the last lecture, we created this material instance for us to use. And in the future, if we need to use this material again, we can just create another material instance and swap out this texture. In this lecture, let's look at how we can use this material to create a dandelion effects. So first, I'm going to go back to my Niagara basic folder, and I'm going to create a new folder. I'm going to call this one 06 dandelion, and double click to open it. So right away, I'm going to create a Niagara system and click next. So if we want, we can build everything from ground up. We can set up the particle size, we can set up the spawn location, and add those different forces modules. Or we can use one of the existing templates to help us achieve what we want. So if you scroll down, you can see there's this emitter, and it's called hanging particulates. And this is perfect for what we want. You can see all the particles will be swirling in a rectangular area. So I'm going to select this one and click this add button. Click finish. So I'm going to name this to ns_dandelion and double click to open it. So you can see this is what this emitter template is doing. And if we look closely at these different modules, so under this emitter update, these two are the one that we've used quite a lot. And under particle spawn, these are the two modules that we know. One thing to look for here, inside of this initialized particle, the sprite size has already been set to be random, and the sprite rotation mode has already been set to random as well. And this is perfect for our dandelion effect. If we don't use random and use onset instead, all the dandelions will be facing the same direction. And under this particle update, there are some forces module that we haven't seen before. So number one is this wind force. I think this name is already clear enough. By using this module, we can apply wind to the particles spawned by this emitter, and we can adjust its scale in here. And there's another module, so it's called aerodynamic drag, and this is newly introduced to Unreal Engine 5.1. And comparing to the old drag that we used, this is more of an upgrade version, and it gives us more control, and it achieves a better result. And other than that, it has this scale sprite size. This is its curve, so you can see the size will increase to its max size, then it will hang there for quite some time, then it will decrease it to 0. And we also have this scale color. So all it's left there to do is to swap out this material. So we need to use our own material in here. Go back to my content browser. I'm going to move that material instance to this folder. So go to my material. I'm going to select this material instance and drag it to this dandelion folder and select move here. I highly recommend you to do the same to put every asset related to your Niagara system into one same folder. This is just in case in the future if you want to revisit some of the VFX, you don't need to jump around between different folders because you might have some textures in another folder, some materials in a folder, and in order for you to see everything, it'll be quite time consuming once the VFX is complicated. Alright, I'm going to open this Niagara system and I'm going to select this material and click this icon to use it. And wait for the shaders to be recompiled. And now you can see we have some dandelions, but we have some issues. You can see the size of it is way too small. I'm going to drag it out in my level first for us to better see it. So go back to my level. You can see we already run out of slots, and I'm going to increase some slots in this room. So after selecting this room, I'm going to increase its length from 5 to 10. And I'm going to duplicate this demo display, and I'm going to name it to Dandelion. Alright, I'm going to drag out this Niagara system and place it in my level. And you can see this is what we get. So the scale is a bit off, and in order to get a better sense of it, I like to get a reference. So I'm going to go to the spot where I'm using this mannequin, select it, and since I'm moving it to a spot that's outside of my field of view, I'm going to hold down Shift on my keyboard. So my camera will follow along this moving. And I'm going to place it on this demo display and drag it here. Alright, so first thing, I'm going to increase its size. To do that, we can go back to the Niagara system, and inside of this initialized particle, we can tweak these two values in here, and then go back to our level and see what it looks like. Or we can just convert these two values into user parameters. By doing that, we can directly adjust these two values in our viewport. To do that, it's fairly simple. We just need to click this button, and in here, I'm going to type user parameter. And you can see it's right there. Here it says re from new user parameter. I'm going to click it. Now this value has been converted into user parameter. So this will be the minimum value for the scale of the sprite. I'm going to be doing the same thing for this sprite max. So I'm going to click here and type user. And click this new user parameter. Now I have two user parameters. In order to find them inside of our Niagara system, you can go to your left. You can see there are 3 tabs in here, and we have 2 user parameters in here. And the best thing about it is, if we now go back to our level, I'm going to press G to show this icon and click this Niagara system, press G to hide it, and scroll up. You can see now we can directly adjust the scale in our level. So I'm going to increase its minimum scale to maybe 6 and its max scale to 9. Now you can see we have much larger dandelions. So this looks alright, but we can make it much better by tweaking some of the values inside of this system. And that will be our first section challenge in the course. So the challenge is, I'd like you to assign our custom material to this existing template hanging particles, and after that, I'd like you to tweak the values inside of it so that you have a better dandelion effects. So maybe the wind force is not strong enough, or the drag is a bit much. Try to use dynamic inputs to give yourself more random values to make these effects better. And remember, user parameters can surely help you to do this. Pause the video now and give this a go, or come back if you need help. Welcome back. How did that go for you? Hopefully you are happy with the effects that you create. Now I'm going to tweak the values for my effects. So I'm going to open this Niagara system. First, I'm going to change it from CPU sprites to GPU sprites in case I want to increase its number significantly. So I'm going to take this GPU compute sim and change its bounds to fixed. Then under the spawn rate, instead of a static value, I'm going to convert it to a dynamic input. So I'm going to select this random range float, and the value that I'm going for will be something like 80 and 100. Alright, something like this. And inside of this initialized particle, I like to keep everything at default. And this shape location, using a box is perfect for this kind of effects. But I like to convert this value into a user parameter. So I'm going to click this button here and type user and select it. So the box size will be something that we can control in our level. And I'm going to go to this wind force. So for the wind speed scale, I'm going to use a random range float. And I'm going to change it to be a value between 3 and 5. And for this turbulence, so I like to have a stronger value. I'm going to use a random range flow as well. So the value I'm going for will be somewhere between 6 and 8. I'm going to keep this aerodynamic drag at default, and this scale sprite size at default, and this scale color. So I don't want my dandelion to fade in, then fade out. I like to use this curve instead. Alright, go back to my level. This is what I have so far. I'm going to decrease their size a little bit, so maybe somewhere between 5 and 7. And I'm going to decrease its box size a little bit. So maybe somewhere between 300. All right, something like this. And because this is a sprite renderer, no matter where we are in our level, these sprites will always be facing us. And this is a relatively cheap effect, but with some custom materials, we can get a quite decent result. What's your dandelion effect like? Is it something similar to mine, or did you create a much better one? Go share your effects in the Discord channel, and I'll see you in the next lecture. Welcome! In the last lecture, we successfully created this dandelion effect. Now, before we move on, there are two issues that I'd like to fix. First, in the last lecture, I set the blend mode of this material to be translucent and I forgot to say back. Now I'm going to say back to be additive and press apply. And the second one is, for this effect, if you look closely at these dandelions, you can see as they're floating in the air, their facing direction is always the same, and that's not really ideal for an effect like this. And we can easily change that by adding a new module to particle update. So I'm gonna select this Niagara system, right mouse button click, and click browse to asset, and press G to hide it. And double click to open my ns_dandelion. So under this particle update, there's another module just for the rotation. So the module is called sprite rotation rate. And you can see it's right there. So if you are ever confused about what a module can do, you can use your mouse hover over it. And usually this can tell you what you'll do. So you can see here it says rotate a sprite over time, input is in degrees. So this rotation rate here, the module will take it as degrees. And all we need to do is change the numbers in here. So I'm going to use a random range float. And the degrees that I'm going for will be somewhere between 90 degrees and 240. Now, if I go back to my level, you can see all my dandelions, they begin to rotate. And if you think the rotating is too much, you can always decrease the number. But I think I'm pretty happy with what I have here. And now you already know that by applying some custom materials, we can achieve many different types of effect. And with some special textures, there is so much more that we can do. And that includes sub-UV animation. So sub-UV animation is also known as a flipbook effect. And it's very powerful when we need to simulate fire or smoke. And in order to set this up, there are a few things that we need. So first, we need a flipbook texture. After having this texture, we'll need to create a custom material based on it. After that, we need to assign this material to our Niagara emitter. Then we need to change its UV image size in there. And finally, we need to define its animation start and end frame. So let's go over this step by step. So for the flipbook texture, inside of the pack that we imported, there are already a lot of flipbook textures. So you can see there are textures for explosion and textures for fire. And I believe there are also some textures for smoke. And we can create some pretty decent fires or smoke from these textures. But there's another pack that I like to import. And in there, we can find more textures with higher quality. So the pack is called this M5 VFX Volume 2 Fire and Flame. And it's another free pack. And it already supports 5.1. All we need to do is add it to our project. So I'm going to add it to my project. Alright, after getting hold of it, same as our last pack, I'm going to copy out the textures folder. So I'm going to select this textures folder and move it to my textures folder and select copy here. And I'm going to rename this to fire_VFX textures. And go to file and click save all. Alright, next thing that I want to do, I'm going to delete this pack from my project. And there's a faster way to do it. So you can right mouse button click and go to where this pack is located on your disk. And you can delete this folder directly from your disk. But only do this when you're sure that no other assets in your project are referencing anything inside of it. So I'm going to first close my project. Then I'm going to delete this folder directly from my disk. And I'm going to restart my project. Alright, now that we have the texture ready, the next thing, we need a material. So go back to my material folder, and here I'm going to create another material. So I'm going to call this m_sub UV master underscore additive. So in the future, if there are other VFX that need to use Flickbook texture, I'm gonna create material instance from this material. Double click to open it. So first, I'm gonna change this blend mode from opaque to additive and change this from default lit to unlit. And right mouse button click, bring in the particle color first. And next thing, I'm gonna bring in a texture. So the texture I'm going for is inside of this fire loop. So there are a lot of fires in here, and I'm gonna go with this big fire too. So select it and bring it in my material editor. And combine these two nodes together. So hold down M on my keyboard, connect their RGB, then press Ctrl+D, duplicate it, connect their alpha. And plug it into opacity, plug this into emissive color. And I'm going to convert this texture sample into parameter. I'm going to call this main texture. And click apply, and go back to my content browser. Now I'm going to create a material instance from it. So click create material instance. I'm going to call this mi_bigfire_additive and move this material instance to my Niagara folder. I'm going to create another folder in here. I'm going to call this 07 sub UV animation and bring in that material instance. Alright, inside of this folder, I'm going to create a Niagara system and click next. This time, I'm going to start with this simple sprite burst again and click finish. So I'm going to call this ns_bigfire and double click to open it. So first things first, I'm going to assign that material instance to this material slot. So I'm going to select it and click this button here. And after that, you can see we have some fires in here. But right now, it is being displayed as a texture. And that's the last two steps that we need to do. So we need to set its sub-UV image size and its animation start and end frame. So to set its sub-UV image size, you can find it under this sprite renderer and go to the section where it says sub-UV. You can see in here, we can set its sub-UV image size. And the two values here, we need to set them based on the number of elements inside of this texture. So if you go back to your material instance, you can see this is an 8x8 texture, and we need to set the numbers there accordingly. So go back to my Niagara system. I'm going to change this value from 1 to 8 and change this from 1 to 8. And now you can see we only have one fire. And so far, this is only a still texture. In order to make it move, there's one module that we need to add under this particle update, and that is called sub-UV animation. And you can see right after we add this module, we get some warning message. So in here, it says no sprite renderer selected. Inside of this dropdown, we can select this sprite renderer. So this is the sprite renderer that we've been using. And now you can see we have fire. And if you are not happy with its play rate, you can manually override that in here. So by default, it will start at 0 frame and it will end at this. And it will end at the last frame. So this is an 8x8 texture, so meaning we have 64 frames. If we want this to play faster, you can change this number from 63 to maybe 128. And now you can see it plays much faster. I'm gonna say back to 64 or 63 maybe. And all it's left there to do is we need to manually tweak some of the values in here in order for this to look right. But before we do that, it's time for a challenge. So a challenge is I'd like you to import the Flickbook textures from this M5 VFX pack. After that, I'd like you to create a custom material and assign that custom material to our sprite renderer. And don't forget to set up the sub-UV image size and the sub-UV animation. Pause the video now and give this a go. Welcome back. Now that we have our basic file ready, we need to begin to tweak the values in here. So first, I'm going to go inside of this emitter state, and I'm going to change the loop behavior from 1 to infinite. And I'm going to delete this spawn burst instantaneous. Instead, I'm going to use spawn rate. And I'm just going to give it a hard-coded value of 50 in here. And now you can see I have a lot more fires. And inside of this initialized particle, so for its lifetime, I want to provide some randomness. So I'm going to select this random range float. And the minimum lifetime, I'm going to say to be 0.5. And the maximum, I'm going to say to be 1.8. Feel free to apply your own values in here. And for the sprite size, I'm going to use random uniform. And for the minimum scale, I'm going to say to be 80. For the maximum scale, I'm going to say to be 130. Alright, now all the fires, they are being spawned at the exact same location. So I'm going to separate them, use the module shape location. And right now, I think the radius of the sphere is too large. So I'm going to set it using a random range float. And the value I'm going for is somewhere between 5 and 10. Alright, we are getting somewhere. And in order for them to look more realistic, I'm going to use the module at velocity. And now you can see some of the particles, some of the fires are being pushed up. Instead of using the linear velocity mode, I'm going to change it to in cone. So now we'll be applying our velocity in a cone shape. And we can define its cone axis in here. So instead of having a value of 1 in x-axis, I'm going to set it to have a value of 1 in the z-axis. Now the fires will be pushed up, and we can set the cone angle in here. So I'm going to change the cone angle from a static value to a random value. And the minimum value, I'm going to try 15, and the maximum value, I'm going to try 30. Alright, something like this. And I'm going to increase the velocity speed in here. So I'm going to use another random range float. So the minimum speed, I'm going to say to be 80. And the maximum speed, I'm going to say to be 90. Now you can see we are already having a better result. Alright, those are the things that I want to set under this stage. And now let's move on to particle update. So first, I'm going to add the module scale sprite size. So generally, the fires below will be smaller and the fires above will be bigger. And the perfect curve for that will be this curve. So it's called ease in. I'm going to use this curve. Alright, something like this. And the last thing that I want to set will be its color. So right now it's not bright enough. And instead of using this scale color module, I'm going to delete it and I'm going to use the color module. So I want to change its color during its lifetime. So I'm going to change this from a static value to this color from curve. So the things that I'm going for is I want the bottom part to be brighter and the upper part to be darker. And to do that, we can manually set the colors in here. So I'm going to say it to be something maybe orangish, somewhere near here. And I'm going to increase its value from 1 to 3. Alright, I'm going to drag out this pen a little bit, somewhere near here. Alright, in the middle, I'm going to add another pen. So for this pen, I'm going to lower its value a little bit. Alright, something like this. And click OK. Let's see what this looks like in our level. So go back to my level. I'm going to drag out a new demo display. And I'm going to change the name from Dandelion to Sub-UV Animation. And I'm going to duplicate this mannequin as well. And place my Niagara system inside of my level. And there you go, we have our fire. And if we want it to look better, we can keep tweaking all of the values here. For example, the speed of the velocity module and the different colors for the color module. And also, in order for this fire to work, it still misses some of the key elements. So normally when there's a fire, there's smoke and possibly some embers. And we're going to be doing all of that in the next lecture. So these are the modules that I used to create my own fire, and you can take a reference of this and create your own variation of it. So maybe you don't like the sphere shape location, feel free to use a different shape, and feel free to choose your own color, and have fun with adjusting all of those values. And in the next lecture, we'll look at how we can create a much better file. I'll see you in the next lecture. Welcome! Starting from this lecture, we'll look at how we can create a flamethrower like this. So before we jump in our editor and create the Niagara system we need, let's analyze this VFX a little bit. So in the future, very likely, you'll want to create some of your own VFX, and it can be from an existing VFX that you see or a type of VFX that you really like. But no matter what you are trying to create, it's very important for you to know what you might need during your creation. And I think it all goes down to this one single question. What do you see? For creating a VFX, same as creating a scene or creating a model, we'll need some reference, and by looking at that reference, there are 3 questions that you can think about. So first one, what renderers do you see? So far, we've only used the sprite renderer, and to create this effect, to create this flamethrower, sprite renderer is enough. But later, when we introduce more renderers, those will be something that can be used in a VFX as well. And oftentimes, for creating a VFX, we'll need multiple renderers to work together. And the second question is, what elements do you see? So in this step, we need to quickly identify the elements we need for creating this VFX. It can be the type of textures we need or the type of mesh we need. You know what I'm talking about when we go over mesh renderer later. And after gathering enough information, the final question is, what forces or material do you see? So you already know that the importance of a material in a VFX. And generally, to create a VFX, but only having the material is not enough. In order to simulate the movement that you want, it'll be great for you to know what forces modules you might need. Right now, I'm not going to give you answers to all of these 3 questions for this VFX, but I'm going to ask these 3 questions again when we finish this VFX. And by that time, you'll have a pretty good idea about the answers. So go back to my editor. I'm going to first duplicate this demo display along with this mannequin, and I'm going to change the name to flamethrower. And after that, I'm going to create a Niagara system inside of this sub-UV animation folder. Same as the one before, I'm going to use the simple sprite burst and connect finish. So this one, I'm going to call it ns_flamethrower and double click to open it. So for this Niagara system, we'll need multiple emitters to work together. And I'm going to name this emitter, so we can press F2 to do that. I'm going to change it to main flame. And after that, I'm going to change the material for this sprite renderer. So click this drop down, I'm going to type mi_bigfire and select it. So the sub image size will be 8 by 8. And in order for the different frames to blend better, I'm going to also take this sub UV blending enabled. Alright, next thing, I'm going to add the sub UV animation module and select the sprite renderer in here. For the start frame, I'm going to give it a random value. So instead of a hard-coded value of 0, I'm going to make it to start between 0 frame and the 5th frame. And for the end frame, I'm going to increase its play rate to 128. Alright, that's the basic setup for the main flame. And I'm going to start from the top to the bottom. So first is the properties. So instead of CPU sim, I'm going to change it to GPU compute sim and change this to fixed bounds. And for this emitter state, I'm going to change it to loop infinitely and delete the spawn burst instantaneous. Use spawn rate instead. So for the spawn rate, I'm going to give it a random value. And the value I'm going for will be somewhere between 300 and 500. Alright. And inside of this initialized particle module, for its lifetime, since this will be the main flame for the flamethrower, and usually those flames shouldn't live too long. So I'm going to give it a random range float, and the value will be between 0.5 and 0.8. Feel free to choose your own values in here. And same as the last fire that we created, I'm going to first use the module shape location and decrease the sphere radius to 10. And the defining force for this type of VFX will be the module at velocity. So I want the flame to move forward, and we can use the same velocity mode as last lecture. It'll be in cone. And we can define the cone axis in here. So having the cone pointing to x-axis is exactly what we want in here. But for the cone angle, I'm going to lower it down to a number of 5. And this inner cone angle, I'm going to give it a number of 3. Alright, time for this velocity. So I'm going to give it a random range float. And the value, I'm going to say to be somewhere between 500 and 800. And now you can see we have the basic of our flamethrower. So I'm going to hold down my middle mouse button to pan my preview window. So you can see all of those particles of these sprites of this fire, they all have the same facing direction, and that isn't really too ideal. We can randomize that by going back to initialize particle, and inside of this sprite rotation mode, I'm going to change it to random. And now you can see this looks much better. And moving on to particle update. So I'm gonna first bring out that scale sprite size and use the same curve that we used in the last lecture. Pretty cool, we're already getting somewhere. And currently I think the size of my sprite, they look way too uniform, and I'm gonna go back to this initialized particle and I'm gonna provide some randomness in here. So I'm gonna use this random range float, and the value I'm going for will be somewhere between 50 and 80. Alright, something like this. And next thing that I want to set will be its color. So I'm going to delete this scale color module, and I'm going to use the color module instead. So use color from curve, and the first pin I'm going to set its color to be somewhere reddish or orangish, and increase its value from 1 to 3. We can always come back to change this later, and drag out this pin a little bit, and left mouse button click to add another pin in the middle. So for this one, I'm going to lower its value down to 1. Alright, that's it. Now let's see what this looks like in our level. So go back to my level. I'm going to bring out this MS flamethrower and drag it up a little bit. And that's it. We have our main flame ready. So comparing to the fire that we created in the last lecture, we are using the same exact material, except we only change some of the values for the forces. And here's what we can get. Looks pretty cool. I think I'm gonna tweak the color of this main flame a little bit. So go back to my Niagara system. I'm gonna move the color to somewhere near here and go back to my level. Alright, something like this. And I'm gonna move this mannequin to the side. Later, when you try to create this by yourself, you can use this as a reference. So these are the modules that I use, and they are pretty similar as the modules we used in the last lecture. So the key factor here is this velocity in cone, and the scale of the speed inside of it will directly determine how fast your fire will move. Other than that, everything should be pretty straightforward. Good luck with this main flame. I'll see you in the next lecture. Welcome! In the last lecture, we created this main flame for our flamethrower, and in this lecture, let's look at how we can smoke for it. So, same as our fire, to create smoke, we'll need to use some flipbook textures. And from the pack that we imported, there are already a lot of smoke textures inside of it. So, first things first, I'm going to create a material for it. Go back to my material folder. I'm going to duplicate this master material. And instead of this suffix additive, I'm going to change it to trans. So short for translucent. And double click to open it. Instead of additive here, I'm going to change it to translucent. Since I know for my smoke, I like to apply some dark colors on it. And note that here, I didn't take this two-sided option. And that's because I know this material will only be used by sprite renderer. So there's really no reason for me to take this. Alright, I'm going to click apply and close this window and create a material instance from it. I'm going to call this mi underscore flamethrower smoke underscore trans and move this material instance to my sub UV animation folder. And I'm going to change the texture. So double click to open it. So the texture I like to use will be from this fire VFX textures, and under this smoke folder, there are a lot of textures we can choose. So the texture that I'm going for will be this texture, so this 1_6 smoke 2. And click this icon in here. Alright, I'm going to go back to my Niagara system. So right mouse button click and click browse to asset and double click to open it. So for the second emitter, since the movement of it will be very similar as this one, I'm going to directly duplicate this main flame and swap out its material. So I'm going to select it and press Ctrl+D to duplicate this emitter. And right away, I'm going to change its name to be smoke. And I'm going to press this icon to solo this emitter. So first things first, I'm going to swap out the material. So click this sprite renderer and select this material and click this icon to swap it out. And now you can see we are getting some smoke, but it's using the color of fire. So I'm going to delete this color module first. And now this is its original color. So I'm going to start to tweak some of its values. For the spawn rate, I don't need this many. So I'm going to press this icon to reset it to default value. And I'm going to just give it a value of 100. Alright, something like this. And for this initialize particle, I'm not going to touch its lifetime, but I'm going to set its initial color. So instead of pure white, I'm going to lower its value down to be something like this. And you can see we have some black smoke. Alright, let's see how it blends with the other flame. So I'm going to click this icon again to show all the available emitters. This is what we have so far. So right now the fire is being spawned at the exact same location as the flame. But I want the spawn location to be moved to the tip of this flamethrower. And to do that, we can set its position offset in here. So I'm going to take it and I'm going to offset the smoke along the x-axis. So I'm going to first give it a value of 120 units. Alright, something like this. And I'm not going to touch this scale sprite size. And I'm not going to touch this sub UV animation. You can do that if you want. I'm going to add one final module and that will be this scale color. So I like to fade out this smoke. And for this scale alpha, I'm going to click this icon in here and select flow from curve. And I'm going to use this curve. So now my smoke will slowly fade out. And go back to my level. Right now I can barely see the smoke. So I'm going to adjust the scale color curve a little bit. So go back to this flamethrower. So I'm going to select the start time of this fading. Now instead of 0 seconds, I'm going to set it to be 0.5. So that I'll have more black smoke before they fade out. And go back to my level. Yeah, something like this. I think I also want to increase its spawn rate a little bit. So go back to this spawn rate. I'm going to give it a default value of 150. Alright, something like this. And go back to my level. And just like that, we now have the smoke. And just by swapping out the texture from a flame texture to a smoke texture, this is what we can get. Later, when you try to create your own smoke, you can use this as a reference. So the key factors here are the material for the smoke. If you want some black smoke, you will need a material that has the translucent as its blend mode. And other than that, everything is pretty similar as our main flame, with only some changes for the values in these different modules. And don't forget, you can always offset your smoke under this initialize particle module. Alright, time to create your own smoke. I'll see you in the next lecture. Welcome! In the last lecture, we created this black smoke for our flamethrower. And in this lecture, let's look at how we can create the blue flame at the bottom and some embers. So go back to my Niagara system. For the blue flame, it's fairly simple. We can just duplicate this main flame. So I'm going to move these two emitters out a little bit. And I'm going to select this main flame, press Ctrl+D to duplicate it. And I'm going to isolate it first. So the first thing that I'm going to adjust is its spawn rate. I don't need this many, so I'm going to reset it to default. And instead, I'm going to use a value to be between 100 and 130. Alright, something like that. And under this initialize particle section, I'm going to decrease its size as well. So it's going to be 10 and 20. Alright, something like that. And for the blue flame, it usually doesn't go that far, so I'm going to decrease its velocity speed as well. So I'm going to reset this value. And I think the default value is good enough. So I'm going to pan my viewport a little bit. Alright, something like this. And I'm going to also decrease this shape location. So instead of 10 for sphere radius, I'm going to decrease it to 2. And the last thing that I want to adjust would be its color. So right now it's using the color from the main flame, but I'm going to change it to something bluish. So I'm going to move the color to somewhere near here. And I'm going to select this pin and delete it. So it's still using some of the flame color. I think I'll just delete this module and start all over again. So I'm going to type color and select color from curve. And I'm going to change this to something bluish and increase the value of it to somewhere near 5. And I'm going to move this pin out And in here, I don't want its opacity to fade so quickly, so I'm going to add another pin in here. Now I'll have more blue flame, and for its end color, I'm going to set it to be something bluish as well, and increase its value to maybe 2. I'm going to show other emitters to see what this looks like. So right now, this blue flame is too close to the origin of this main flame, and I'm going to offset it a little bit. So go back to my initialized particle and take this position offset. Give it a default value of -10 in the x-axis. Alright, something like that. And I think I will increase the speed scale for this at velocity module. So instead of a 25, maybe I'll give it a value of 50. And go back to my level. So this is what I have so far. I think I'm going to increase the brightness of the blue flame a little bit. So go back to my Niagara system and go back to the color. So I'm going to increase its value from 5 to 10. And click OK. Go back to my level. Yeah, something like that. This looks much better. And there you go. We have our blue flame ready. And it's time for a challenge. So a challenge is, I'd like you to create the bottom blue flame for your flamethrower. As you can see, I just duplicated the main flame and I changed some values for it. So it's mainly about the velocity scale in that velocity module and the color for the color module. And you can always tweak the values when something is not right. Pause the video now and give this a go. Welcome back. How did that go for you? Hopefully you have your blue flame ready. And now I'm gonna add some embers for this flamethrower. So instead of using the default sprite material, I like to create my own material for it. So go back to my material folder and I'm gonna create a material instance from this single texture master. So click create material instance. I'm gonna name this mi_flamethrower ember_additive. And I'm gonna move it to my sub UV animation folder. And open this material instance, I'm going to swap out this texture. So the texture I'm going for would be from this realistic VFX texture. And inside of it, you can see there's this texture. It's called T_spark_B. And I think the pattern of it is perfect for the things I want. So I'm going to swap it out. And this is what I get. Now go back to my flamethrower. I'm first going to rename this emitter to blue flame. And I'm going to create a new emitter after this smoke emitter. So right mouse button click, we can directly add an emitter inside of the Niagara system. And the template that I'm going to be using is this simple sprite burst. Alright, I'm going to first isolate it so that we can see it better. So first I'm going to swap out this material and go back to my content browser. Go back to this sub UV animation, select this material instance. I'm going to fill it in. You can see this is what we have so far. First thing that I'm going to set this loop behavior to be infinite, and I'm going to use spawn rate. And the value for it doesn't need to be very high, so I think a value between 20 and 30 will be enough. Now it's this initialized particle, so I'm going to give it a random lifetime, somewhere between 1 and 2. The sprite size mode, I'm going to choose this random uniform. And I think 10 and 20 will be reasonable in here. Feel free to use your own values. And I'm also going to set its initial color. So I'm going to go for something yellowish or something orangish and increase its value quite a bit. Maybe try 10 or 5 and click OK. Now we only have this one single ember in our world origin. So I'm going to first use a shape location. And the shape primitive, I'm going to use box and plane. And I'm going to click play in here. Alright, something like this. I'm going to pan my viewport a little bit. And go back to my initialized particle. I'm going to set its rotation to be random. And keep using the module at velocity. Set it to be in cone. The speed of it, I'm going to use a random value between 200 and 300. Now you can see we have some flying embers. So I'm going to disable emitter isolation, see what it looks like with the other emitters we have. So currently the size of the box is too huge. I'm going to increase the size of my viewport window a little bit. So I'm going to decrease the size of it. Go back to my shape location. I'm going to decrease its value for the z-axis, so maybe a value of 70 would be better. We can always come back to tweak the values later. And inside of the particle update, first I'm going to add the module scale sprite size and use this curve instead. Alright, I'm going to go back to my level and see what it looks like. Alright, we are getting somewhere. And next thing, I like to adjust its spawn location. So go back to my Niagara system. To do that, we can go inside of this initialize particle and set its position offset in there. So I'm going to offset it for 100 units in the x-axis and something like that. I think I need to increase its lifetime a little bit, so go back to my Niagara system. And for its lifetime, I'm going to go with the value between 2 and 2.5. And just to provide it with more randomness in its movement, I'm going to use the module curl noise force. And for the strength of the noise, I'm going to increase it to 80. And for the frequency of the noise, I'm going to decrease it to 10. Now go back to my level. Yeah, I think this looks much better. And just to add in a little more details, I'm going to use the module drag. So the embers will hang for a little bit. Yeah, I think this already looks decent enough. And one last thing that I like to add. So while these embers are floating in the air, I want to alter their brightness a little bit. So in real life, the brightness of the ember should change during their lifetime. And there are multiple ways for us to do that. So if we want to do it inside of Niagara system, so inside of this scale color, we can change the curve for its alpha. So it can reach to 0 at some point and go back to 1 at some point. Or we can do that inside of our material. Go back to my content browser. I'm going to add some nodes to my master material. So go back to my material folder. Double click to open this single texture master. So the node I'm going to use is called sign remapped. So just to quickly show you what this node can do, I'm going to change the preview mode to a plane and right mouse button click this node, start previewing it. So for the side face, I'm going to pass in the node time and plug it in. And you can see after that, the color of my surface begins to change. So this node allows us to output a value between value 1 and value 2. And we can multiply our emissive color with this output. And by doing that, we can achieve the flashy ember we want. So for the first value, I'm going to start previewing this node. I'm going to hold down S on my keyboard to bring out a scalar parameter. So later, this will be something that we can directly adjust in material instance. I'm going to call this brightness min and give it a default value of 0.5. And I'm going to duplicate this parameter. I'm going to change its name to brightness max and give it a default value of 5. And plug this into value 1, plug this into value 2. And I'm going to use a multiply node to combine these two values. So plug the value of this pin into socket B and plug this into socket A. Now plug the final output into emissive color. And now you can see we can get this flashy effect. And there's one more node that I like to add. So not every one of the material instance will need this effect. So I want to enable it per material instance. And to do that, I'm going to use a switch parameter. If you are from my material course, hopefully you are finding all of this familiar. So basically, this node allows you to select true or false in material instance. And if it's true, the value of this pin will go through to the final output. If it's false, the value here will go through to the final output. So I'm going to change its name to should change brightness. And when it's true, this will go through. And when it's false, a value of 1 will go through to the final output. So by multiplying 1, this wouldn't really change anything to the final output. And plug this into socket A. And I'm going to organize these nodes a little bit and click apply. Now go back to my material instance, double click to open this and flamethrower. Now you can see we get this switch parameter. And after I tick it, I have 2 more parameters that I can adjust. And if we look closely at our embers, you can see their brightness start to change. So I'm going to be a little extreme in here. So the brightness min, I'm going to change it to 0.1. The brightness max, I'm going to change it to 6. And now we have exactly the effect that we want. Looks pretty cool. So these are the things that I did for creating the ember effect. So there are some things from Niagara emitter and there are some things from material. So feel free to take a reference of the modules that I use inside of my Niagara emitter. And if you are from my material course, you should be able to find all these nodes look familiar. And if you are not, you just still want more explanation, or you are still having trouble in understanding how these different nodes work, feel free to leave a question in the Q&A section or in the Discord channel about it. I'll be happily providing you with the assistance you need. Alright, time to create your own embers. I'll see you in the next lecture. Welcome! In the last lecture, we successfully created this blue flame and these flying embers. If you want your blue flame to be longer, you can do that by increasing its speed in the add velocity module. I'm not going to touch that, but I'm going to change some of the values for my embers. Right now, I don't think it matches with the movement of this flame. So go back to my Niagara system. Go to my embers emitter. First, I'm going to decrease its spawn rate to somewhere between 10 and 20. Then I'm going to increase its lifetime. So its maximum lifetime, I'm going to increase it to 3.5 seconds. And inside of this add velocity module, I'm going to increase this velocity speed to 300 and 450. And go back to my level. Yeah, something like this. I think this looks much better. And the last thing that I want to add is I want to create some heat distortion for this flamethrower. By adding this heat distortion to our flamethrower, I think it could really increase some interesting details. To achieve this, we need two things. First, we need a Niagara emitter. We can just use a sprite renderer for us to do this. And that's the only thing that we need from Niagara. The heavy lifting thing for this effect needs to be done through material. And more specifically, there are three things that we need to do inside of our material editor. So first, we need to have a translucent object. Then we need to adjust this refraction rate. So refraction is just the bending of light, and this will happen when the light enters from one transparent substance to another. And Unreal has made this really easy for us to do. And in order to simulate this effect, one last thing we need is normal map. And this same technique could be applied to a water material. So let's look at how we can do this from material. Go back to my editor. I'm going to go to my material folder. I'm going to create a new material. I'm going to call this m_heat distortion master and _ trans. So later, if other VFX needs this, we can just create material instance from this material. Double click to open it. I'm going to set its blend mode from opaque to translucent. Now we'll have a translucent object. Then I'm going to change its shading model from default lit to unlit. So first I'm going to hold down 1 on my keyboard and I'm going to plug a 0 into the opacity socket. Now we'll get a totally transparent object. And next thing, I'm going to plug a value into this refraction socket. Hold down 1 again and bring out this float. I'm going to change its value to be 1.33. So this is the refraction rate for water, and plug this into the refraction socket. Now we can already see something. There's already some kind of light bending happening for this plane. Alright, we're getting somewhere. And the last thing we need is some normal map for this normal socket. And we can find that inside of the pack we imported. So go back to my content browser. I'm going to go to the textures folder, this realistic VFX texture. And scroll down. You can find there's this T noise normal B and there's this T noise normal A. Let's see what they will do to this effect. So I'm going to bring both of them in. And go back to my material editor. So I'm going to try this one first. Plug this into the normal socket. And you can see this is the heat distortion that I'm talking about. And this one it has much more details. If I plug this into the normal socket, you can see we get a much stronger distortion. So I think for our purposes here, this one here is enough. So I'm going to delete this texture sample node and plug this into the normal socket. Alright, we are getting somewhere. In order for this effect to look better, apparently we need to somehow move this heat distortion. And there's one node can help us easily achieve that. So the node is called panner. Basically what this node does is it scrolls our texture. and we can specify which axis do we want to scroll it in here. So for example, now I give it a value of 0.1 inside of the y-axis and plug this into the UV socket. Now you can see it's slowly scrolling our texture, and by tweaking the value here, this can help us to achieve what we want. But with this kind of setup, we have one issue. Let me just quickly show you. So I'm gonna click apply in here and go back to my content browser. I'm gonna create a material instance from this master material. So I'm gonna name this mi underscore flame heat distortion underscore trans and move this material instance to my flamethrower folder. So you'll be inside of this UV animation. Alright, and double click to open my Niagara system. So I'm gonna quickly add in another emitter. So right mouse button click and add this simple sprite burst. In order for us to see this emitter better, I'm gonna isolate it first and I'm gonna swap out its material. So selecting this heat distortion and click this icon. Now you can see we have a very small plane in the middle, so I'm going to increase the size of it. I'm going to try 200 for now, so that we can see it. And I'm going to change this emitter state, this loop behavior, from once to infinite. Alright, go back to our level. You can see this is what we get. But apparently there are more things that we need to do. So first we need to hide this seam for this heat distortion. At this moment it's too obvious that this is a texture. So whenever you want to hide something inside of your texture, oftentimes you'll need a mask. So I'm going to go back to my master material. So right now, this refraction is entirely depending on this normal map. For the areas that have the normal map, we can get this heat distortion. And all we need to do is, we need to remove this effect for the seam of this plane, which means we shouldn't have normal map in these areas. In order to have a 0 for the normal socket, we can't just plug in a value of 0. That's just not how normal map works. Instead, we need to use a vector 3. So I'm going to hold down 3 on my keyboard to bring it out. And I'm going to give it a default value of 1 in the z-axis. So the strength of the normal map depends on the value of x and y. So the stronger the values for the x and y, the stronger the normal strength will be. And having a 0 in the x and y, we'll get no normal strength. And now all we need to do is we need to combine these two nodes together. And we can easily do that by using a lerp node. So I'm going to plug this 0 normal strength into socket A and plug this normal strength into socket B. Now all we need to do is we need to find a value to plug into this alpha socket. And that can easily be our mask. So when the value inside of the alpha socket is 0, value A will go to the final output. When it's 1, value B will go to the final output. And we have the perfect mask just for that. So go back to my content browser. If you go inside of this fire VFX textures, go inside of this fire single, you can see there's this big fire underscore single. And this is the exact mask that we need. So I'm going to isolate its channels. First, I'm going to only show the red channel. So this is the mask that we can use in the red channel. And this is in green channel. This is in blue channel. This is its alpha. So I think I'm going to use the red channel. Or you can use the green or blue channel since they all have the same values. And remember, this is just a value ranging between 0 and 1. Alright, go back to my master material. I'm going to bring in this mask. And I'm going to plug the red pin into the alpha socket and plug this into the normal socket. Now you can see that seam is gone. And if you want to adjust your mask a little bit, you can easily do that by using a power node. So I'm going to use the power node in here. And I'm going to preview this node. So this is currently its value. Now the value is 2. Right after I change it, say maybe 5. This is what we get. So I think a value of 1.2 would be enough. Alright, something like that. So the power node can be used to adjust the contrast of a mask. I'm going to stop previewing it. And now I'm going to create some parameters for this material so that we can adjust it in a material instance. So there are 4 values that I like to control. I like to control its speed x, speed y. I want to control the contrast of this mask, and I want to control this refraction rate. So we need 4 scalar parameters, or we can use a vector for parameter. So we can hold down V on our keyboard and left mouse button click to bring it out. So I'm going to change this to distortion settings. So this is the same as bringing out for scalar parameters. And we can change each channel's name in here. So I'm going to click this drop down. Inside of the channel names, for the red channel, I'm going to name it to be speed X. For the green channel, it will be speed Y. For the blue channel, it will be mask contrast. And for the alpha channel, I'm going to call it refraction rate. I'm going to give it a value of 1 for the speed Y. For the mask contrast, I'm going to give it a default value of 1.3. For the refraction rate, I'm going to try 1.2. Now all we need to do is plug these values in. So first will be the speed X and speed Y. We can combine these two single flows together and plug them in into this speed socket. And we can use a node make flow2 to do that. And plug this into Y socket, plug the result into the speed socket. Alright, for the mask contrast, I'm going to plug it in into this power node. And I'm going to adjust this pin a little bit, drag it down to organize my graph a little bit. And last thing will be this refraction. So I'm going to plug this into the refraction socket and delete this node and drag this node down. Alright, just like that. Now we have our heat distortion ready. I'm going to hit apply and go back to my level. Now you can see we have a much nicer heat distortion. All I need to do now is to adjust some of its properties and maybe the size of the plane so that it aligns with our flamethrower. So go back to my Niagara system. I'm going to first disable emitter isolation and I'm going to hit play. Now it's very hard to see that, so I'm going to go back to my level. Now you can see it's at the origin of our flamethrower and I want to lift it up and I want to move it to the tip of this flame. So go back to my Niagara system. I'm going to isolate it. First, I'm going to set its position offset. So click this initialize particle. For this position offset, I'm going to set it to be 300 units. And in order for us to see better, I'm going to increase its sprite size to 500 units. And go back to my level. So right now, it's at the end of the flame. Let's see what it looks like. Alright, this looks good enough. Now I'm going to lift it up a little bit. So inside of this position offset, I'm going to lift it up 200 units. Alright, something like this. Right now, I think this is too much. But this does look good. You can see we have the exact effect that we want. So I'm going to decrease the size of this plane a little bit. So go back to my Niagara system. Instead of uniform, I'm going to set it to be non-uniform. So I want to set the size of its X and Y separately. So for the X-axis, I think a value of 200 units should be enough. For the Y-axis, 300 units should be enough. And you can see now the position of it is not correct. And that's because the pivot point of this plane, because we changed the size of it, and now the offset values for it is too much. So by default, the pivot point of this sprite will be at the middle, and I like to offset it to the bottom of this plane so that we can scale this plane in the y-axis. And we can do that by going back to our Niagara system inside of our sprite renderer. We can adjust this default pivot point in UV space. If your mouse hovers over it, you can see that if the value is 0, 0, the pivot will be at the upper left. And if it's both 1 and 1, it will be bottom right. The middle is 0.5 and 0.5. So I like to keep the value for the x-axis, but I'm going to change the value for y-axis to be 1. So now the pivot will be at its bottom. And I'm also going to set the sprite size to be a user parameter so that we can adjust it faster. I'm going to type user parameter in here. And I'm going to change the name. So I'm going to right mouse button click and click rename. I'm going to change it to heat distortion size and go back to my level. Now you can see that plane is way up. So I'm also going to change this position offset. I'm going to say back to 0. And I'm going to adjust its size in the level. So click this Niagara system. I'm going to try 150 for now, or maybe 200. And for the x-axis, I'm going to change it to maybe 300, 350 for the y-axis, maybe 250 for the y-axis. Alright, something like that. And I'm going to try to look at it from different angles. Alright, this already looks good enough. And if we are not happy with how fast this texture moves, we can adjust it inside of this material instead. And thanks to this parameter we just created, so we can change its speed width. So if you think it moves too slow, you can change it to maybe 1.5. Now you can see it moves much faster. I think 1 is enough. And the mask contrast, if you change it to 2, we'll get less heat distortion. But right now nothing is changing for mine. The reason why nothing is changing is because I forgot to plug this pin back in. So I'm going to plug this into the alpha socket and click apply. Now go back to my level. You can see we get less heat distortion. So I think I'm going to change it back to 1.2. And the refraction rate, if you try to take this value, say 1.5 now, you see we get much more distortion. And if you decrease it to 1, we get less heat distortion. So I think 1.2 is enough. Alright, something like that. Yeah, I think I'm quite happy with what I have in here. Later, when you try to implement this by yourself, these are the nodes that I use inside of my material graph, so you can take a reference of it. And same as usual, if there are nodes that you still don't understand, feel free to post a question about it. And for the Niagara part, you can set the pivot point of the plane inside of the sprite renderer. In that way, you can scale the plane more easily. Feel free to refer back to the video if you need help. Now, time to create your own heat distortion. I'll see you in the next lecture. Welcome back. Now let's do a little recap on the VFX that we just created together. Looking back at these 3 questions, I'm sure at this point you already know the answers to them. So for this VFX, we've only used the sprite renderers. And for the elements, do you still remember what textures we have used? Well, we've only used some flickbook textures for fire and smoke, and some normal map for this heat distortion. For the forces and material, those are the key things to help us to pull this VFX off. And I hope you still remember what the modules we use. You don't need to remember all of them, just a few that we use all the time. The reason why we are doing this is, instead of knowing how to create one VFX, in the future you can apply all of these skills and knowledge to the VFX that you want to create by yourself. And eventually, you're gonna get to a point where by looking at something, you can say, oh, that's curl noise force, that's a velocity from cone, oh, that's a material effect, and those are the nodes that I need. You're not gonna get there right now, but as we create more and more VFX, as you see more and more examples, it's gonna happen. And all the things that we'll be doing inside of this course will help you to get closer and closer to that spot. So feel free to write down anything that you think are important on the demo display, and those will be the things that you can revisit in the future. And usually, they are the most valuable things. Alright, however, back to my project, there's one more thing I'd like to do. Say now we really like this VFX, and for our Niagara system, say we really want to create a thumbnail for it. We can easily do that by opening our Niagara system and click this thumbnail button, and this will capture the viewport as its thumbnail. So you can see, now we have a custom thumbnail for our Niagara system. And I think I don't really like this background. We can get rid of that by going back to the Niagara system. I'm going to adjust my viewport a little bit so I can capture this VFX a little bit better. Alright, something like that. And you can go to your preview scene settings. And inside of it, you can see there's this environment drop down. Click it and you can untick this show environment. And we can change this environment color to completely black, something like that. Yeah, I think this looks much better. And click this button again. And go back to our level. You can see now we have a much better thumbnail. If for some reason you don't have this tab, you can enable it by going to this window and take this preview scene settings. Alright, now I'm gonna enable my environment back. And that's pretty much it. After creating this effects, now if we go back into our textures folder and open this realistic VFX textures. So for all the flipbook textures, if you know how to use one, you know how to use every one of them. So there are a bunch of variations that you can create by the same techniques. So if you'd like to create your own explosion, you can do that. You'd like to create different types of fires, you can do that. And there are a lot of other fire textures inside of this folder. Say you like a torch, these are the textures that you can use. Or you want some candle fire, these are the textures that you can use. And all the things you've learned so far can be applied to all of these textures that you just saw. Alright, starting from next lecture, we'll look at what other renderers could do. And this is only the beginning. We're gonna create a lot more amazing VFX. When you're ready, I'll see you in the next lecture. Welcome! In this lecture, we'll look at how we can use the mesh renderer inside of Niagara system. So first, I'm gonna go back to my Niagara folder, and I'm gonna create another folder. So I'm gonna call it 08 mesh renderer, and inside of it, I'm gonna create a Niagara system directly, and choose new system from selected emitters, and select this simple sprite burst, and click finish. So for this one, I'm going to call it ns_mesh renderer and double click to open it. So to change an emitter's renderer, we can go down to this sprite renderer and we can directly delete this renderer and we can select the other renderers we want in here. So I'm going to select mesh renderer and go back to the selection tab. So you can see under this mesh rendering section, there's this drop down says meshes. And inside of here, we can specify the mesh that we want. So inside of here, I'm going to type cube. And you can see these are the default cubes from Unreal. I'm going to select this SM_cube02. If you're not seeing this, make sure you have this show engine content enabled. So after that, you can see in my viewport, I'm spawning a particle. And that particle is this cube that I just specified. And this is everything. Because this is a particle, that means we can apply different forces modules to it. We can scale its color, we can scale its size, we can change its rotation. Everything that we've done to sprite renderers can be done inside of mesh renderer. Everything we've learned can be applied in this renderer. And that leads us onto our challenge today. So your challenge is, I'd like you to use mesh renderer in render stage. After that, I'd like you to spawn the particles using the mesh you specified. And lastly, try to apply forces to your particles. Based on the modules that you already know, see if you can create something interesting. Pause the video now and give this a go. Welcome back. How did that go for you? Hopefully that was easy enough for you to do. Now I'm going to apply some forces to my particles. So first, I'm going to change its looping behavior from once to infinite. And I'm going to delete the spawn burst instantaneous. Same as our sprite renderer, I'm going to use spawn rate. And I'm going to give it a random value, so somewhere between 5 and 15. Under this particle spawn, one thing to look for here is, so far we've only set size using this sprite attributes, but I'm sure you've noticed that no matter what values we put in here, this won't affect this mesh. And that's because in order to set its scale, we need to do it under this mesh attributes. And the sprite attributes is just for sprite renderer. So for this mesh scale mode, I'm going to change it to random uniform, and I'm going to give it a value to be between 0.5 and 1.1. And for the particle spawn, module shape location can be used for mesh renderer. And now you can see we are spawning these cubes in a sphere. And I'm going to use the same module at velocity. Now you can see we are slowly lifting these cubes up. I'm going to change it to in cone. And the cone axis, I'm going to set a 0 for the x-axis and give the z-axis a value of 1. And for the velocity speed, I'm going to give it a random value. So somewhere between 70 and 150. Alright, something like that. I think the size of the cubes might be too huge. So I'm going to decrease the max scale from 1.1 to 0.8 maybe. And inside of this particle update, so the scale color is no longer affecting these cubes. And that's because the material of this cube, the particle color, is not used in there. So we won't be able to fade out this cube. So I'm going to delete this module. And instead, I want to change its rotation. So you can see there's already a module and it's called Update Mesh Orientation. After selecting it, you can see now I'm rotating these cubes. And for this rotation vector, I'm going to click this drop down, change this to a dynamic input. I'm going to select random vector. And now these cubes are rotating randomly. And the last thing that I want to do, I want to scale it. So for sprite renderer, we can use scale sprite size to do it. But for mesh renderer, we need to use a different module. So it's called scale mesh size. And now you can see we get this scale factor. So now I want to decrease their size during their lifetime. There are two ways for me to do that. First, I can directly convert this vector from curve. In that way, I'll have control over each individual value. So I can scale its x, I can scale its y, I can scale its z. We're going to need this later for some VFX that we create. But for now, I'm going to select vector from float. Now you can see that vector has been converted into a single float. And now we can directly convert this flow into a curve. So I'm going to select flow from curve and use this curve that we've been using. Now you can see we are scaling our cubes. All right, I think this is what I need. I'm going to bring it into my level, see what it actually looks like. So I'm going to duplicate this demo display and I'm going to change its name to mesh renderer. And I'm going to bring in my Niagara system. And just like that, now we are spawning static meshes inside of our Niagara system. How cool is that? So these are the modules that I use for my mesh renderer. Feel free to try them out yourself if you haven't used them before. And same as always, write down anything that you think are important on the demo display. And I'll see you in the next lecture. Welcome! In the last lecture, we used mesh renderer to create this simple VFX, and now, after understanding it, the true power of mesh renderer lies within the ability to use custom mesh. We can use Niagara to spawn the meshes that we create in a 3D modeling software, and that could provide endless possibilities. So to do that, let's hover over to Blender. Now here I am inside of Blender. If you've never used Blender before, don't worry, you could still follow along. We are not going to create some complicated meshes in this course. And eventually, this is something that you'll have to do by yourself in the future if you want to create your own VFX. So right now, I just want to create some simple plans inside of Blender and export it to Unreal. So first, I'm going to select this cube and press X and click Delete. And I'm going to press Shift A to add and select Mesh and click Plan. Alright, as simple as that. This is the most basic model and it's actually quite useful for a VFX. And for a VFX mesh, before we export it to Unreal, there are several things that we need to consider. So first, it's important that we have a correct pivot point. So for achieving certain type of effects, it's very common that we need to scale our mesh. And when scaling a mesh, it will be done based on the pivot point. So it's important that we get this correct in the 3D modeling software before we use it in our Niagara system. Otherwise, it will be just a pain for us to adjust everything. Of course, same as our sprite renderer, we can offset its pivot point, but why not get everything correct and save us some time? And the second thing would be its UV. So UV will directly determine how the texture is going to be displayed on this mesh. For this simple plan, we don't need to worry about that. And we'll come back to this topic when we create more meshes. And the third one, personally, I think is also an important one, is the mesh's orientation. Same as the pivot point, this can also be adjusted in Niagara system. But since it's really simple to adjust, why don't we just do it correctly before we export it? And for this plan, the orientation is fixed. So I want this plan to face up. And this is the exact orientation that I want. So as long as we can have a correct pivot point, this is something that we can export to Unreal. Now looking at this mesh, where do you think its pivot point is? So right now you can see there's this yellow dot. So this is its pivot point in Blender. So now if I lift this plane up, so you can do that by first selecting it, then press G. Now you can move this plane, and I'm going to press Z to lock the movement on the Z axis, and I'm going to lift it up a little bit to somewhere here. Now if I export this to Unreal, where do you think its pivot point will be? Let's try it out first. So after selecting this mesh, I'm going to go to File and select Export and select this FBX. So I already have my output folder specified, and I'm going to name this mesh to SM_plane on ground. And don't forget to take this selected object, and you can keep everything else at default. Alright, I'm going to click Export FBX. So go back to Unreal. I'm going to create another folder to hold all the meshes that we're going to create. So I'm going to create a new folder and I'm going to call this one meshes. And double click to open it. So this is where I exported that plan. I'm going to drag it inside to Unreal and minimize this window. So I'm going to keep everything above a default, and this material import method, I'm going to select this drop down and choose do not create material. And after that, I'm going to click import all. And we don't need to worry about this message. We can just close this window. Now the plan is inside of our project. Let's drag it out to our level. Now you can see the gizmo here is the pivot point of this mesh, and let's compare it with the mesh in Blender. So now hopefully you have a pretty good idea about the pivot point of the mesh in Blender. So by default, when you export a mesh from Blender and import it to Unreal, the pivot point will be at the Blender's world origin. It doesn't matter where the pivot point is inside of Blender. So right now, this mesh's pivot point is at the center of this mesh. But when we want to use it in Unreal, it will be at the world origin. So I'm going to move it back to world origin. We can easily do that by first selecting this mesh, then press O+G. And this will cancel any of its movement and move it back to the world origin. Now I'm going to export this mesh again. So I'm going to go to File and choose Export, select FBX. And I'm going to override this file. So click Export FBX and go back to my Unreal. We can just right mouse button click this asset and choose Reimport. And now you can see we have the correct pivot point for this mesh. And this is something that we can directly use inside of Niagara. And it's time for a challenge. So your challenge is, I'd like you to create two planes in Blender. So one plane will be on the ground, just like the one you saw, and another one will be facing the camera. What do I mean by that? So that means when I drag out the plane, I want its orientation to be facing the camera. Something like this. So that means we need to have a correct orientation in Blender before we export it to Unreal. See if you can figure out which axis is which in Blender comparing to Unreal. Once you figure out which axis is correct in Blender, be careful with the pivot point for your planes. So for these two planes, we want the pivot point to be at the center of the mesh. And don't worry if you made a mistake or the orientation is wrong. Same as I did, you can always go back to Blender, export it again, and re-import it inside of Unreal. And last step, sample your own meshes in Niagara system. So after you have your planes ready, see if you can sample them inside of the Niagara emitters. Pause the video now and give this a go, or come back if you need help. Welcome back. How did that go for you? Did you successfully have a plan that's facing the camera? Let's see how it can be done. So first, I'm going to hide this plan. We can press H to hide it. And I'm going to press Shift+A and select Add Mesh, Add Plan. And for this one, I'm going to rotate it. So we can press R. Then we can rotate the plane however we like, but which axis is facing the camera. Let's jump back to Unreal and figure it out. Basically, we want this plane to face the y-axis. So if you look at this gizmo here, that means we want this plane to have an orientation of positive y. And in Blender, we can see it's a gizmo in here. So if we want it to face positive y, in Blender, it actually means negative y. So I'm going to select this plane and I'm going to rotate it. So you can see the negative y is this side. So I'm going to press R and press X to lock the rotation on the x-axis. And I'm going to type in 90. So now I should have the correct orientation. And its pivot point will be its world origin. So right in the center. And that's exactly what I want. And before I export it, since I already changed its rotation, I like to apply its rotation. So we can do that by pressing Ctrl+A, and in here, we can select which one we want to apply. So I want to apply its rotation. And the reason why we want to do that is this is extremely important for our UV. But since this is a simple mesh, it wouldn't really be a big deal if we forget to do this. But it's a good habit, and you'll understand why very soon when we need to deal with UV in the future. So before you export a mesh to Unreal, you can click this icon here. And make sure its rotation and scale is all at its default value. So 1 for scale and 0 for rotation. Alright, I'm going to export this So go to File and select Export and select FBX. And instead of plane on the ground, I'm going to change its name to SM_plane face camera and click Export FBX. Now go back to Unreal. I'm going to delete this first and I'm going to drag in this plane face camera and select Import All. Now I'm going to drag out this plane. Alright, this is exactly what I want. So right now, this plane is facing the camera. And this is perfect later when we place it on our demo display. And the last thing, I want to quickly use Niagara system to sample these two meshes. So go back to my Niagara folder. I'm going to create another folder. For this one, I'm going to call it 09 Custom Mesh. And double click to open it. Create a Niagara system. Go to Next, select Simple Sprite Burst. Change its name to ns_custom mesh and double click to open it. So first I'm going to change its loop behavior to be infinite and delete this sprite renderer. Change it to mesh renderer, and inside of the meshes here, I'm going to select my SM_plane on ground, and you can see here it is. Now I'm going to duplicate this emitter and I'm going to change its mesh to SM_plane face camera. And now you can see we cannot see the mesh, and that's because by default the mesh will be single-sided. And by applying a two-sided materials to it, we can get rid of this back face issue. Alright, right now I think this is good enough. I'm gonna put this Niagara system into my level. So I'm gonna delete this mesh and duplicate this demo display and change its name to custom mesh and dragging in this Niagara system. And just like that, now we are sampling our own custom mesh. In this lecture, we went through the difference between pivot point for Blender and Unreal. And we also use Niagara system to sample our custom static mesh. Now that with the ability like this, by applying some custom materials to our mesh, we can achieve so many different types of VFX. And we'll look at how we can do that in the next lecture. I'll see you in the next lecture. Welcome! In the last lecture, we created these two custom meshes inside Blender, and we used Niagara system to sample these two meshes. Now, there are just two simple planes and they don't really look exciting. In this lecture, let's look at how we can create textures for them, and we'll be doing it all inside of Unreal. So, in Unreal, we can directly bake out textures. And to do that, there are two things we need. So first, we need the material. And second, we need the render target. The material here will directly determine the patterns on the texture. In other words, the content of it. And the render target will act as a container for us to bake out the texture. I'm sure you already know what material is. Let's talk about this render target. A render target is used in many different ways inside of Unreal, and it's quite a powerful tool. So first, a material can draw to render target, and this behavior can be triggered by code. And what's best about it is this behavior can be done in editor or runtime. So for example, in editor, we can use it to help us to create some textures. And in runtime, it can achieve so many different types of in-game effects. Things like footprints on the ground, make the water surface interactive when a character walks into it, dynamically draw a texture onto the wall, and the list goes on and on. For our purposes here, we only want to use it to create textures directly inside of Unreal. So this is the texture that we'll be creating. You can see this is just a simple pattern, a simple ring. To do that, there are three things we need. So first, we need a material that contains this pattern. Then we'll need a render target. And the last thing, we also need a blueprint. Remember, this behavior is triggered by code, so we need to use blueprint to write some code to help us achieve this. Of course, a simple pattern like this can easily be created inside of Photoshop, but this lecture will be a perfect introduction for the things we want to do next. Alright, let's look at how we can set this up in Unreal. Go back to Unreal. Inside of my Niagara Basic folder, I'm going to create another folder. I'm going to call this 10 Simple Ring and double click to open it. So first, I'm going to create a material that contains this ring. So I'm going to call it m_simple ring and double click to open it. So for a simple pattern like that, I don't need these many sockets. So I'm going to change the shading model from default lit to unlit. So I only need to have access to this emissive color. Then I'm going to create my first primitive shape. And there's a material node that we can directly use. So that node is called radial gradient exponential. So what this node does is simple. It simply generates a y dot with fall off. So I'm going to start previewing it and change the preview mesh to plane. So you can see this is what I get. And to get a ring, we can use one bigger dot to subtract a smaller dot. So first, I'm going to give it some function inputs. For the radius, I'm going to give it a default value of 0.4 and plug this into radius. Now you can see I have a smaller dot. And for its density, because I want my ring to have a harder edge, so I'm going to increase its density quite a bit. I'm going to use a default value of 100 and plug this into density. And now you can see I get a basic shape like this. Alright, I'm going to start previewing this node. Then I'm going to duplicate these 3 nodes, press Ctrl+ D. And for this one, I'm going to change its radius from 0.4 to 0.37. So I should get a smaller dot. And I'm going to use a subtract node in here and plug this into the emissive color. And that's it. You can see now I have a ring. So these are the nodes and the values that I use for creating the shape we need. I'm going to pause here for 2 seconds. So if you want to follow along, you can pause here, go ahead and do this, or come back anytime when you finish watching this video. Alright, now after having the shape ready, next thing I need a render target. So I'm going to right mouse button click and go to textures and select this render target. So I'm going to name it to be rt_simple ring and double click to open it. Now before we draw anything to a render target, it's important we set its properties first. So the first thing that I'm going to set is size X and size Y. So this will directly determine what kind of resolution our texture will have. So instead of 256, I'm going to change it to 512 and 512. And this resolution, I think, is more than enough. And I'm going to keep everything else at default, but I'm going to change the format in here. So instead of this RGBA16F, I'm going to change it to RGBA8 sRGB. So basically, this means the texture later we created will have 4 channels and also have this sRGB turned on. And this is the default setting for most textures we use in Unreal. And that's it. That's the basic setting for render target. So here are my settings for this render target. I'm going to pause here for 2 seconds and then we'll move on. Alright, now that we have a material ready and we have a render target ready, the next thing we need a blueprint to help us create the textures. And more specifically, we need the code inside of it. And in the next lecture, we'll look at how we can do that. I'll see you in the next lecture. Welcome! In the last lecture, we successfully set up a material and a render target. In this lecture, let's look at how we can use a blueprint to draw our material to render target. Understanding how a blueprint works is essential for creating VFX because eventually we'll need to use blueprint to help us to spawn VFX as they are tightly connected to gameplay. And if we don't know anything about blueprint, we'll just end up with having a bunch of VFX that we don't even know how to use. So in this lecture, let's look at how we can write some code in Blueprint. So go back to my editor, I'm going to go to this textures folder. Since this blueprint is highly related to textures, I'm going to put it in here. So right mouse button click and click blueprint class. So you can see here it's asking us to pick which class do you want to be the parent class for this blueprint. And depending on the class that we choose here, we could inherit different functionalities. For our purpose here, we only need to be able to place this blueprint inside of our level. So simply choosing actor here is enough. And you can see here it says an actor is an object that can be placed in the world. Alright, I'm going to click actor and I'm going to call this BP_texture_baker. And double click to open it. I'm going to go to this event graph, and instead of using events, I like to use functions. So we can create functions directly in here. So I'm going to click this add button to add a function, and I'm going to call this function bake texture. I'm going to go to the right in here And under this graph section, I'm gonna take this checkbox for call in editor. So what this does is, this allows us to call this function inside of our editor directly. And to prove this function is working, I'm gonna use a print string. And the string, I'm gonna change it to working and connect this pin to here and click compile. Now go back to my level. I'm gonna drag out this actor and lift it up a little bit. I'm going to press G now to show the icon of it. And you can see inside of the details panel, we get a new button. And here it says bake texture. So this is the function name that I just set. After I click this button, you can see a string has been printed to the screen. All right, this is working. And we can use this function to create textures directly inside of our editor. Now go back to this blueprint. I'm going to delete this node. So the function we need is called draw material to render target. And you can see it takes two function inputs. First one is this texture render target. Second one is the material. And we can use the drop down here to select which render target we want to use, which material we want to use. But before I set anything in here, there's one thing that I like to go over. And that is the function types for Blueprint. This function, this is the one that we just used. So it's called draw material to render target. And this function is called add actor world rotation. Can you notice a difference between these two functions? So the function on the left, this is a non-static function. And the function on the right, this is a static function. And the difference between a static and non-static function is this word right here, the target. So to access a static function inside of Blueprint, as long as we know the name of the function, we can directly call it inside of the event graph. But to access a non-static function, we'll actually need an object reference. An object reference is just like a variable. We can use this object reference to call this function add actor world rotation. And that's because a non-static function only exists in the object that owns this function, and to access this function, we need to have a reference of this object. Otherwise, we just cannot call the function. And you already know that an object reference is just a variable that contains value. But for this object reference, it's empty. So we declare a variable that has a type actor. But this is just a variable. In order for it to work, we need to actually find a way to assign the value to it. In other words, the actor that we are trying to reference in here. And if we are trying to access an object that's not even there, we'll get a crash. So when we have an object reference in Blueprint, it's always important to check whether or not it's valid. So you can see this node here, it can help us to check this input object. And if this variable indeed holds the object that it's trying to reference, then this its valid pin will fire. And if it doesn't, then this pin will fire. And in C++, declaring an object reference is also known as creating a pointer, and an empty object reference is known as a no pointer. So always check your pointer in C++, always check your object reference in Blueprint. Now go back to my function. If you use your mouse hover over this function, you can see it says target is Kisma rendering library. So most of the static functions exist inside of a library, and they are like global functions that we can access anywhere else we want, as long as we know the function name. In C++, that's the case, but in Blueprint, we'll have some constraint. But generally, the rule applies. Now, instead of selecting the value inside of the dropdown to make it a hard-coded value, I like to use two object references so that we can manually assign them different values. And we can use this to bake out any textures we like. So first, we can go to the variables here and click Add. So by default, it will be a Boolean. And we can manually change the variable's type in here. So you can see the first input pin is expecting an object type of texture render target 2D. And we can manually search that type by typing in texture render target. And you can see it's right there. And in here, we can select we want this to be an object reference. After that, we can access this variable by dragging it into our graph and select get. Then we can connect this into here. Now, this is a bit slow. And in Blueprint, we can directly create object reference by promoting this input pin to variables. So first, I'm going to delete this variable I just created. Then I'm going to drag out this pin And you can see here we have two options. We can either promote it to local variable or promote it to variable. A local variable will only be visible to this function and cannot be accessed anywhere else. While a variable, once we mark it as public, we can access it in other places, for example, in the details panel. So I'm going to promote it to variable, and I'm going to change its name to render target to draw. And for the material here, I'm going to do the same thing. So drag out this pane and select promote to variable. And I'm going to change its name to material to draw from. Now you can see we are passing two object references into this function. And currently, they are both empty. First, I'm going to click compile in here. So you can see we can assign them values in here, and they are both empty. So for a static function, passing in empty object references probably won't matter, because inside of this function, there will be code to prevent us from accessing empty object references. But it's always a good habit to check. So I'm going to drag out this render target to draw, and select get, and drag out this pin. I'm going to type is valid. So you can see we have two options here. So the first one will just be a simple node, which returns a boolean. If this is valid, this will return true. I'm going to drag out this material and select get, and I'm going to type is valid. And the second one, this will be just a node, which has execution pin that we can connect something to. But for our purposes here, since we are checking two object references, I'm going to be using the same node. So I'm going to use the first one. So I'm only going to proceed if both of the values are valid. And we can combine two booleans together by using another node, and it's called AND boolean. So if this is true and this is true, then I'm going to use a branch node. So we can hold down B on our keyboard to bring it out. And the condition will be this boolean in here. So if the condition is true, do this, which is draw material to render target. All right, I'm going to click compile. And I'm going to click this variable, and I'm going to click this eye icon in here to mark it public. And do the same thing for the second one, and click compile again. Now go back to my level. You can see under this bake texture, I have a render target to draw and material to draw from. And we can directly assign them values inside of the viewport. And later we can use this to bake out other textures if we need. All right, I'm going to go back to my Niagara folder and go to this simple ring. So for the material to draw from, I'm going to select this m_simple ring and click this icon. And for the render target to draw, fill in this RT simple ring and click bake texture. And now you can see we are drawing the material to the render target. And we can use the right mouse button click and select this create static texture. Just like that, we got ourselves a texture. Now double click to open it. So this is what you will be seeing, a transparent background. And that's because we have alpha channel for this texture, and this alpha channel is overriding the RGB. If we disable this alpha channel, you can see this is the pattern. So I'm going to enable it back. And since we are not using the alpha channel, we can take this checkbox here. So it's compressed without alpha, and this will disable this alpha channel. And you can also reduce this resource size. So I'm going to take it, and now you can see we can see the texture. I'm going to close this window and go back to my level. So right now we can already draw a material to render target, and we can create textures from this render target, but we can make this function much better. So I'm going to first delete this texture, go back to my blueprint. So when I fire this function, not only do I want to draw material to render target, I also want to create a texture directly from it. And we can do just that. The function is called render target create static texture. I'm going to select it. And you can see this is a static function. It also belongs to this Kismet rendering library, and it has a few function inputs. So first one, which render target should we use to create textures from? Well, that will simply be our render target to draw. So I'm going to get it and plug this into this render target. And the second one is the name. So what's the name for the texture? Instead of texture, I'm going to change it to texture from render target. And I'm going to keep this compression settings at default and this MIP settings at default, and connect this pin to here and click compile. Now go back to my level. When I click this button again, you can see a texture has been created, and I'm going to disable its alpha because we don't need it. Now go back to my level. I'm going to change its name to T_simple ring. And just like that, we have our texture baker ready, and it's time for a challenge. So a challenge is Same as I did, I'd like you to draw material to render target using Blueprint. After that, with the new texture you just created, see if you can use it in Niagara system with your custom mesh. Remember the two planes we created in Blender? Try to see if there's anything interesting that you can create based on what you have right now. So you already know how to assign custom mesh inside of a Niagara system for mesh renderer. See if you can figure out how to assign your material to it. And for the material, you can just use our single texture master and create a material instance from it. Pause the video now and give that a go, or come back if you need help. Welcome back. How did that go for you? Now I'm going to create some VFX using the texture that I just created. So inside of this folder, I'm going to directly create a Niagara system and select new system from selected emitters. And go down, select the simple sprite burst, click finish, and I'm going to call this ns_simple ring. And double click to open it. So first I'm going to delete this sprite renderer and select mesh renderer. And I'm going to change its mesh to sm_plane face camera. Now this is simply just a flat plane and I want to apply some materials on it. So I'm going to click this enable material overrides and click this button here to add an element. So in here we can specify what material we want. So I'm going to go back to my material folder and I'm going to select this single texture master, create a material instance from it. I'm going to call it mi_simple ring additive and move it to the folder. So I'm going to drag it to this simple ring and click move here. Now double click to open it. So I'm going to swap out this dandelion texture and I'm going to select this simple ring in here, click this main texture and click this icon. Alright, now we have our materials ready. And just to make it look even better, I'm going to take this shoot change brightness. Then I'm going to go back to my Niagara system. So select this mi_simple ring additive and click this icon here to use that material. And you can see now we have our ring in here. So I'm going to first change its loop behavior from once to infinite. And for its initial color, I'm going to give it something maybe orange-ish and increase its value to 5. Now you can see it's glowing. And just to add a little bit of flavor inside of particle update, I'm going to use scale mesh size. And after I add the module, you can see we cannot see the particle anymore. And that's because in order for this module to work, we need to first set the mesh scale in here. So instead of unset, I'm going to change it to uniform. And now we have our particle back. Inside of this scale mesh size, I'm going to click this drop down in here and select vector from float. Then I'm going to convert this float to a curve. Now you can see our plane is shrinking. That looks like our ring is shrinking. And we can change the curve in here depending on the result that we want. So if I change it to this curve, we'll get an effect like this. Or if I change it to this, we'll get an effect like this. I think I'm going to go with this one. All right. I'm going to go back to my level and I'm going to drag this Niagara system into my level. So first I'm going to increase the length from 10 to 13 maybe and duplicate this demo display. Change its name to texture baker and I'm going to drag out this Niagara system and move it up a little bit. All right. And the last thing that I want to do is, so you can see our texture baker is here and I like to give it some visual representation, so that when we hide the icon, we can still see it. And to do that, we can add a component to it. So I'm going to click this edit bp_texture baker. And inside of this component section, I'm going to click add. The components that I'm going to add would be a text component. So you can see it's called text render. And go to my viewport. So this is what it looks like. Now I'm going to change its content from text to texture baker. And I'm going to rotate it a little bit. So I'm going to rotate it 90 degrees and I'm going to increase its font size. So instead of 26, I'm going to change it to maybe 35. And click compile. Now go back to our level. You can see we have a visual representation of our texture baker. Now I'm going to move it to this demo display. And now if we hide the icon, we can still see it. And if we want to click it, it will be much easier for us to do so. In this lecture, we successfully drew material to render target, and we also went over some basic coding principles inside of Blueprint. And after that, we also used our created texture on the custom mesh that we created. Great job! I'll see you in the next lecture. Welcome! In the last lecture, we successfully set up this texture baker and we applied our created texture to our custom mesh. Now that you already know what the mesh renderer could do, in this lecture, we're going to look at how we can use the ribbon renderer. So first, I'm going to go back to this basic folder and I'm going to create another one. I'm going to call it 11 ribbon renderer and double click to open it. Inside of here, I'm going to create a Niagara system and select this new system. Go to Simple Sprite Burst and click Finish. So I'm going to name this ns_ribbon renderer. Double click to open it. So by default, when we choose this Simple Sprite Burst to start, it will be using this sprite renderer, and we can delete this and add the renderer we want. So we are going for this ribbon renderer. And after we do that, you can see we cannot see anything. There's no particle inside of our world. Actually, there's already particle in there, but just because of the special features of this ribbon renderer, we cannot see anything. First, I'm going to set this loop behavior from once to infinite. Then I'm going to drag this Niagara system to my level. So I'm going to duplicate this demo display and change its name to ribbon renderer and drag in this Niagara system and lift it up. So right now, we still cannot see anything, and that's because we need to increase its spawn count. So I'm going to delete this instantaneous and add in spawn rate. So the default number Unreal uses is 100 for ribbon renderer. I'm going to be doing the same thing. Alright, that's the spawn rate taken care of, and there's one more thing that we need to set, and that is the width of the ribbon. So we can do that by either going to this ribbon attributes, or we can click this button. So for this ribbon width mode, I'm going to change it from unset to direct set. And for its width, I'm going to go with 10 for now and go back to my level. And now if I drag this Niagara system, you can see we can see this ribbon. And right now its color is at its default color, so I'm going to change its color. Go back to this all. I'm going to change its initial color to something orangish and increase its value. And click OK. Now we have moved this Niagara system again. Now you can see we get a colorful ribbon. And the most general use case for this ribbon renderer is actually something like this. So first, I'm going to go to this third person folder and go inside of this blueprints. And double click to open this BP_third person character. Alright, after getting inside, I'm going to click add here to add a component to this character. You can see by default, a character already has many components. I'm going to add one more, and the component is called Niagara Particle System Component. So I'm going to select it, and I'm going to leave its name at default. And for this Niagara system, I'm going to use this ribbon renderer. So I'm going to go back to Niagara Basic and select my ribbon renderer and click this icon here to use it. Now, after we do that, this Niagara system will be attached to our character. I'm going to click compile in here and go back to my level. So I'm going to change my world settings in here. So go to my world settings for this game mode override. I'm going to select this BP third person game mode. So now when we click play, we'll be using that character. Alright, I'm going to click play. And I'm going to begin to move. Now I think you already have a pretty good idea at what this renderer could do. So what does this mean? Well, this means weapon trail effect, character dashing effect, and that's the most basic attributes of this ribbon renderer. So it can achieve what the other renderers couldn't do. So these are the settings that I just set. I first changed my renderer inside of this Niagara emitter. Then I set my ribbon width and color in this initialized particle module. Then inside of this BP third person character, I add a Niagara component and assigned this Niagara system to it. So if you want to try this out for yourself, I'm going to pause here for 2 seconds, or feel free to come back anytime. Also, don't forget to change your game mode to third person game mode. Alright, now that we know what this ribbon renderer could do, but that's not all of it. There's another that is very commonly used. So I'm going to go back to this ribbon renderer folder, click Niagara System, and click Next. Inside of all these templates, we have this dynamic beam and this static beam. So for these two emitters, they are both using the ribbon renderer as well. So I'm going to first use this static beam and click Add, click Finish. I'm going to name this to ns_static beam and double click to open it. And now you can see this is what this emitter looks like. And these are the modules it uses. So this is already set to be infinite, and we have these other modules that we can use to adjust its properties. And there are so many types of different effects that we can create just by this. And it's time for a challenge today. So your challenge is, I'd like you to create Niagara system from this static beam. After that, I'd like you to figure out how to adjust its length, its width, and its color. See if you can quickly identify which modules you need to use. Pause the video now and give this a go. I'll come back if you need help. Welcome back. How did that go for you? Hopefully that was easy enough for you to do. So to adjust this static beam, the names of these modules I think are quite straightforward. For example, if we want to adjust its length, we can go to this beam emitter setup and we can adjust its beam end in here. So if I increase its value now we get a much longer beam. If I decrease it, we get a much shorter beam. And we can also take this use beam tangents. And if we do that, we will get something like this. So how this can be used in games, for instance, we can use it for the projectile's trajectory. And if we want to do that, using dynamic beam will be much better than this static beam, because the tangent of the dynamic beam can be calculated every frame. So I'm going to untake this use beam tangents. And I'm going to go to this initialize particle, so we can determine its lifetime in here. And there's not much we can do inside of this bone beam, but inside of this beam width, this is how we can adjust its width. And by tweaking this curve, we can get the beam shape that we like. So now you can see I get a shape like this, and we can add a key to this curve by pressing the middle mouse button. And if I lift this key up, now you can see the width of this beam has changed. And if we want to delete this key, we can select it and press delete on our keyboard. Now I'm going to lift this key up. And I think I'm going to add the key at the end. And first I'm going to select it and press 1 on my keyboard to convert it into a smoother curve. And I'm going to lift this key up until I have something like this. Maybe I want to lift it, alright, something like this. And I want to increase its beam width, so we can tweak this value here for this scale curve. Now if I increase it to 15, you can see the width of it has changed. So I think I'm going to go with the number of 20. And a shape like this is perfect for the trail of a projectile. And if we want to change its color, we can go to this particle update. So this is its default color. I'm going to change it to something like this and increase its value to 10 and click OK. Alright, something like that. Now I'm going to drag it into my level. So I'm going to drag in this NS static beam and lift it up. And press G on my keyboard. Now we have a static beam like this. And another place that you might want to use this is for the bullet for a shooter game. So if you decrease the width of this beam and adjust its color a little bit, this can be used the bullet that's been fired from a gun. Right now, this still doesn't look very exciting, and that's because usually we don't use this default beam material for this beam. So if I open this ribbon renderer, you can see it's using this default ribbon material. Generally, we want to use our own material to achieve different types of game effects. And in the next lecture, we'll look at how we can build a material like that. I'll see you in the next lecture. Welcome back. This will just be a short lecture to prepare you for the material that we want to create next. So if you are from my material course, this should be no problem for you. And in case you aren't, this lecture is gonna better prepare you for what's coming next. So first I'm gonna duplicate this demo display and I'm gonna rotate it and move it to the other side of the wall. And I'm gonna change its name to UV manipulation. And after that, I'm gonna drag out the planes that we created inside of Blender. So it'll be this plane face camera, and I'm gonna rotate it 180 degrees so that it faces this side. And I'm going to move it up. So this will be the preview plan that we use later. And inside of my Niagara folder, I'm going to create another folder. I'm going to call this examples. So later, if we need to make more examples, I'm going to put them all inside of this folder. And double click to open it. I'm going to create a material. I'm going to call this m_UV example. And double click to open it. So first, I'm going to create a texture sample node. And I'm going to select the texture in here. So the texture I'm going to use will be that T_simple ring and plug this into the base color. So now we get this simple ring and we can manipulate the UV of this texture by using the node texture coordinate. So the first thing that I like to do will be control styling. So I'm going to hold down M on my keyboard, bring out this multiply node, and inside of the socket B, I'm going to use a scalar parameter. So you can hold down S to do that. I'm going to name this UV tile and give it a default value of 1. Plug this into socket B. Plug this into UVs. Alright, I'm going to click apply, go back to my level. I'm going to create a material instance from it, and I'm going to call this MI_UV example. And I'm going to assign the material instance to this plan. So drag it inside. And we can control the UV tile inside of the material instance. You can see right after I increase the value, the texture tiles more. And if I decrease the value, the texture tiles less, and the pattern gets larger. So I'm going to reset back to 1. So that's the first important concept, UV tile. Now go back to my material. The second thing that we can do is UV offset. And it's very similar as this setup. I'm going to select this texture coordinate and duplicate it. I'm going to use an add node. So I want to have the ability to both offset this texture horizontally and vertically. So we can do that by creating 2 more scalar parameter. I'm going to call this U offset and duplicate this node. I'm going to call this V offset. And there's only one socket. We can combine these 2 scalar parameters together by using the material function make flow 2 and plug this into Y, plug the result into the socket B, and plug this into UV socket and click apply. Go back to my level. Now inside of my material instance, I can offset U and V individually. So you can see now I'm moving this circle horizontally, and if I change the value for V offset, I'm moving the circle vertically. And this is another important concept for the material we want to create next. And these are the nodes I use. So I'm going to quickly comment them. So these 3 nodes, they can control the UV tile. And these nodes below, they can control UV offset. So as an optional challenge for you, if any of this is new to you, feel free to go try this out for yourself. So same as I did, you can duplicate another demo display and then drag our plan as your preview mesh, then create these nodes separately and use a material instance to adjust the parameters to see what they will actually do to the texture. Alright, go pause the video and try this for yourself if you need. Welcome back. Now that you know, we can use these individual scalar parameters to control the UV offset of this texture, and we can make this even better by using a noise texture. So I'm going to disconnect this pin and move these nodes up. And I'm going to bring out another texture coordinate node, and I'm going to bring out a texture sample node. So the texture that I'm going to sample, I'm going to select it in here. So it will be T_noise. So you can see this is the default noise texture from Unreal Engine. And if you're not seeing this, make sure you have this show engine content enabled. So I'm gonna use this T_noise01 and bring out an add node. So same as these 2 static values above, for a noise texture, it simply contains values ranging between 0 and 1. And if we use these values to offset this texture, then we could get a much more random result. So I'm going to connect the red channel into the B socket. In here, you can also use the RGB, green or blue channel. It really doesn't matter. They all contain the same value. Alright, I'm going to plug this into the UV socket. And you can see this is what I get. I'm using a noise texture to distort the original pattern. So for the white values, that means the values there are 1. We are offsetting the texture. And for the black values, we are not touching it. And that's how we can get a result like this. And right now, the texture itself has been distorted too much. So that means we need to somehow decrease the strength of this noise texture. And we can easily do that by using a divide node. So originally, if the value is 1, using the divide node, it will become 0.5. And if I plug this into socket B and increase the values inside of the B socket, so say I increase it to 10, and now you can see we can get a result like this. And this is another important technique that we're going to use later by using a noise texture to distort another texture. And that's not the only usage of a noise texture. We can even use a noise texture to dissolve the original texture. So you already know that it only contains a value ranging between 0 and 1. If I multiply the RGB with the red channel from this texture, what's the result going to be? Let's figure out. So I'm going to connect this into the base color. And now you can see this is what I get. So for the black values, because they have a value of 0, so we won't be showing those areas. And for the white values, since they have a value of 1, we'll still be showing those areas. So a noise texture can also be used to dissolve a texture. I'm going to drag this node down a little bit. And there's one more thing that I like to mention. Now already we have a bunch of nodes, and for the material that we want to create next, if we don't organize it, it's going to get complicated and messy very soon. And to do that, we can assign different parameter groups to the parameter inside of the material editor. So say right now, I convert this to a parameter and I call it main texture. So I can assign a group in here. So now I'm going to give it a group of 01 main texture. And the sort priority here will determine which row this parameter will be shown. So I'm going to say to have a sort priority of 1. And I'm going to convert this into a parameter as well. I'm going to call it distort texture. And I'm going to give it another group as well. I'm going to call it O2 distort and give it a sort priority of 1 as well. And I'm going to convert this into parameter. I'm going to call it dissolve texture and change its group to O3 dissolve and change its sort priority as well. So the number here doesn't really matter if we only have one parameter inside of this group, but it's going to matter a lot when you have a lot of parameters. And now if I click apply, go back to my material instance, you can see all these 3 textures, they have been put into the groups that we just set. And these are the nodes that I use to achieve the things you just saw. So if this is completely new to you, feel free to pause the video here and go try this out for yourself. And these will be the things we need next when we create the material for our VFX. Alright, go try this out for yourself if you need, and I'll see you in the next lecture. Welcome! In this lecture, let's look at how we can create material so that we can swap out this default ribbon material to make this ribbon renderer much better. So this is the effect that I'm going for. And you can see, comparing to that default ribbon material, I'll have holes and have different patterns on the VFX itself. And to achieve this, we'll need 3 textures. So first is this main texture. And this will directly determine the look of this VFX. And we'll need 2 other noise textures, so they will be responsible for distortion and dissolving. So let's get hold of this main texture first. So this is another texture pack that we're going to import, and it's another permanent free pack. Inside of it, there are a bunch of VFX made by the old Cascade system. We are not interested in those, but we will be using the textures that this pack can provide. So you can see under this supporting engine versions, it does not support 5.1, but that doesn't matter. You can just add this 5.0 version to our project. So I'm going to click this add to project. So make sure you have ticked this show all projects, and I'm going to select my project in here. And for the version here, we can just change it from 5.1 to 5.0 and click add to project. Alright, after adding the project, same as usual, I'm going to move out its texture folder. So click this drop down here, and the texture folder is under this effects folder. And if you scroll down, you can see there's this effects underscore textures. I'm going to move this out, so I'm going to drag it to our own textures folder and click copy here. After that, I'm going to go to file and click save all, and go back to my textures folder. I'm going to rename this to be infinity underscore VFX textures and double click to open it. So this is a massive texture pack. And we're pretty much covered for all kinds of VFX that we want to create by using the textures from it. So you can see under this damage folder, we have some really good looking crack textures. And under this fire, this is what we can get. And we have textures for ice and textures for lightning. We're going to be using some of them later. And there's another folder that I like to move out from this pack. So it's under this effects folder, and if you scroll down, you can see there's a folder that says effects meshes. So inside of it, there are a lot of meshes that's made for VFX. I'm going to copy this folder out as well. So I'm going to drag this folder to our own meshes folder and click copy here. And go to file, click save all. And go to my own meshes folder and open this effects meshes. So this is another massive pack that contains multiple meshes for VFX. Once we have more understanding of VFX meshes, there are literally countless VFX that we can create from all the resources we have. But we are not going to go into them right now. Alright, after that, I'm going to delete this folder. So I'm going to go to File, click Save All again. Then right mouse button click my content folder and click this Show in Explorer. After that, I'm going to close my project. And I'm going to delete this folder right away from my disk. And click yes. After that, I'm going to restart my project. Alright, now, after having all the resources, let's start to build our own material. So I'm going to go to my material folder, right mouse button click, and click material. I'm going to call this m_pen distort master _ additive, and double click to open it. So first thing first, I'm going to change its blend mode to additive, change its shading model to unlit, and I'm going to bring in a texture. So the texture that I'm going to use will be from that Infinity pack. It will be under this fire folder, and I think this one works great for the static bin and the ribbon renderer. So I'm going to drag this texture into my material folder and connect its RGB to emissive color, change the preview mesh to plane. So this is what I get. Alright, first thing, I'm going to convert this into a parameter so that later if we want to use it for other VFX, we can just swap out this texture. I'm going to call this main texture, and I'm going to put it into its own group. So it'll be O1 main texture. And set its sort priority to be 1. And next, I'm going to use the panel node. So I want to scroll this texture. And for the speed X and speed Y, I like to have two parameters to control it. So hold down S on my keyboard. So this one, I'm going to call it main texture U speed and give it a default value of 0.1 and duplicate this node. I'm going to call it main texture V speed and give it a default value of 0. And I'm going to use the function make flow2 to combine these two flows together and plug this into the speed. And one more thing, I also want to put them into their corresponding group. So instead of group, I'm going to select this O1 main texture. So priority for this parameter will be 2, and for this one, it will be 3. Alright, and connect this pin into UVs. And now you can see we are slowly scrolling this texture. And I'm sure you can see that inside of the panel node, there's another socket for texture coordinate. And this is where we can distort this texture. And for that, I'm going to bring out another texture sample node. And I'm going to change its texture to T_noise. And if you scroll up, you can see from the pack that we just imported, it already contains a few noise textures. We're not going to use them now. Instead, I'm still going to use this noise texture from engine and select it and convert this into a parameter. So I'm going to call this distort texture and put it into its own group. So it'll be O2 distortion and give it a sort priority of number 1. And same as the main texture, I like to scroll this distort texture as well. So I'm going to duplicate this panel node, plug this into the UV socket. And same as below, we need 2 more parameters. Hold down S to create the first one. I'm going to call this distort texture U speed and give it a default value of -0.1. Put it into its own group and set its sort priority to be number 2. Alright, I'm going to duplicate this parameter and I'm going to change the name to distort texture V speed and give it a default value of 0, change its sort priority to be number 3, And same as below, combine these two values together. So use a make float2 function and plug this into the speed socket. And that's the basic setting for the distort texture. And in order to have the distortion, we need to use the texture coordinate node. And we can use an add node here. So the value that we're going to add will be from here. So instead of connecting the pin right into here, I like to use a name reroute node. So basically, this can cache the value coming out of this node, and we can use this cached node anywhere else. So I'm going to call this cached distort texture output, and I'm going to use that cached node instead. So bring it out and connect this into the socket B. And move these three nodes down a little bit and drag them down, connect this into the coordinate node. And now you can see this is what I get. So right now the distortion is too much. So that means we need to add some values to control the distortion amount. And we can do just that. So inside of this distort texture, I'm going to drag this pin out and use a divide node. And I'm going to use a parameter to control the amount that we should decrease. So I'm going to bring out another parameter. I'm going to call this strength decrease amount and give it a default value of 5 to begin with. Put it into its own group, O2 distortion. And for the sort priority, I'm going to set it to 5 and plug this into this B socket. Alright, instead of plug the output of this directly into this cached node, I'm going to add a switch parameter. And that's because not every noise texture we're going to use will need to decrease their strength. So for the ones that we do, we can enable this switch parameter. And for the ones we don't, we can just use its default value. So for the name of this parameter, I'm going to call it decrease distort strength. And I'm going to connect this into true, connect this into false, and connect this into the output socket. And I'm going to give it a default value of true. And now you can see this is what we get. And before I forget, I'm going to put this switch parameter into its own group. So I'm going to put it inside of this O2 distortion and give it a sort priority of 4. So this will be above this parameter. And I'm going to quickly comment out these nodes. So this will be distort texture. And I'm going to click apply. Let's see what this looks like inside of our material instance. So go back to my level, go to my material folder. I'm going to create a material instance from it. And I'm going to call this mi underscore ribbon underscore additive and move this to the ribbon renderer folder. So drag it to this folder and select move here. Now go inside of this folder. I'm going to open this ns static bin. And I'm going to swap out this material. So I'm going to select it and click this icon in here. And you can see right now we get a completely different look. And the reason why we are losing the color is we are not using the particle color node. So let's fix that. Go back to my material. Same as above, I'm going to cache the output from the main texture. So I'm going to drag out this pin and use another name reroute node. I'm going to call this cached main texture output and disconnect this pin. And I'm going to quickly comment these nodes. So I'm going to call them main texture. Now I'm going to bring out that particle color node. So type particle color and use the cache the main texture output. So multiply it with the RGB and plug this into socket A. And plug this into the emissive color. And now we should have control over the color inside of Niagara system. Click apply. Go back to my Niagara system. Now you can see we have the color back. I think I'm going to change it to something purplish. And click OK. Yeah, something like that. And if we go back to our level, this is what we get. Alright, we already have some interesting flavor over this particle effect. And let's finish that material. So besides the particle color, we also need to plug something into the opacity socket. And let's go back to this texture. So if I clicked this magnifying glass and go to where the texture is located, double click to open it. And by default, it already has alpha channel. So if we isolate all these different channels, the values inside of alpha channel, we can use it as the opacity mask. But this isn't always the case. For the textures that we're going to use later, some of them may not have the alpha channel, and if that's the case, we'll need to deal with it differently. But for now, for this one, we can just use the alpha channel. So go to where this main texture is located. I'm going to use another name reroute node in here. I'm going to call this cached main texture alpha output. And I'm going to use that cached node down below. So we can select it and use a multiply node to convert them together. And plug this into the opacity socket and click apply. Go back to my level. I think I need to increase the width of my bin quite a bit. So go back to my Niagara system. Under this bin width, I'm going to give it a default value of 50 and go back to my level. Yeah, something like this. So one last thing that I like to add would be the dissolve texture. So we can use a noise texture to dissolve this main pattern. And to do that, I'm going to use the same noise texture as a parameter, and we can always swap it out later. So I'm going to change its name to dissolve texture and change its group to 03 dissolve. And for the dissolve texture, I'm going to be doing the same thing. So I want to pan it. Plug this into the UV socket. And I need two parameters to control its speed. So hold down S to bring one. I'm going to call it dissolve texture uSpeed and put this into its own group. So it'll be 03 dissolve and give it a sort priority of 2. I'm going to give it a default value of 0.2 and duplicate this parameter. I'm going to call this dissolve texture vSpeed and give it a default value of 0 and change its sort priority to be number 4. And use a make flow 2 to combine them together and plug this into speed. Alright, same as above, I'm going to cache its output. So I'm going to cache this red channel and I'm going to call this cached dissolve texture output. And down below, we can use the values from there. So I'm going to directly multiply the value with its alpha channel. So I'm going to use that cached dissolve texture output and use another multiply node. So this will determine what the final mask will look like. And plug this into opacity socket. And you can see this is what we get. And right now, if you think the dissolve amount is too much, same as the distortion, we can control it. So before this cached node, I'm going to bring out a scalar parameter. I'm going to call this dissolved amount. And I'm going to give it a default value of 1. So to control the dissolve strength, we can use a lerp node to do that. So if the value inside of the alpha is 1, then the value inside of socket B will go through. And as we decrease the value inside of our material instance, say we decrease it to 0, then the value inside of socket A will go through, which will be a value of 1. So multiplying 1 wouldn't really change anything to the final opacity mask. And I'm going to put this parameter into its own group. So it'll be 03 dissolve. And that sort priority, I'm going to change it to 4. And there's one more thing that I like to do. So for this dissolve amount, I like to clamp its value. So you can see in here, we have slider min and slider max. I'm going to change this slider max to be 1. So later when we adjust this in material instance, it can only go as high as 1. Alright, I'm going to click apply and let's see what this material instance looks like. So go back to my ribbon renderer, open this material instance, and you can see this is what we get with 3 groups and 3 texture parameters. Now let's try to adjust this value. Say now I want my main texture to move faster. I can change this, for example, to 1. And now you can see we get a much faster moving. I'm going to enable the real time inside of the material instance viewport. So we can do that by go to here and take this real time. And you can see the texture inside of the preview window begins to move. And if we want to change the distort amount, we can take this parameter. So this decides how much we want to decrease its strength. If I change it back to 1, you can see this is what we get. And if I change it to 10, this is what we get. So we can get a completely different look. And for this dissolve texture, we can also change how fast it moves as well. So if I change the value to 1, this is what I get. And if I change the value of dissolve amount to 0, now we get completely no dissolve. So I think the value for 08 will suffice. And I'm going to decrease this main texture USB, change it back to 0.2 maybe. Alright, something like that. Now that with the material like this, not only can we use it for ribbon renderer, we can also use it for the VFX that we are going to create later. And I'm sure you can already notice the importance of a noise texture for VFX. A different pattern could totally alter the look of the VFX, so having different types of noise texture can help us to achieve more interesting variations. And in the next lecture, we'll look at how we can create noise textures directly inside of Unreal. Alright, let's do a little bit of recap. So this is all the nodes that I use for my distort texture. And if you look closely at it, there's really nothing too fancy. All I did was use panner node and use two parameters to control how this texture should be panned, and add another switch parameter to decide whether or not we want to decrease its amount. And these are the nodes that I use for main texture and the dissolve texture. And they both use the similar setup as our distort texture. So feel free to come back to use them as a reference if you ever get stuck at creating your own materials. And finally, I combined all of those nodes together with this particle color node so that we can control its opacity and color inside of Niagara system. And this is my end result with a material instance looks like this. So take your time. And it's time to create your own pen distort master material. I'll see you in the next lecture. Welcome! In the last lecture, we created this pen distort material, and we created this material instance based on that. And we also use this to swap out this default ribbon material, and we get a VFX like this. In order for us to see better, I'm going to increase the lifetime of this static beam. So I'm going to right mouse button click and click this edit. And go inside of it, I'm going to go to this initialize particle and increase its lifetime to 5 seconds. And now I should always have this static beam inside of my level. And we can also swap out the material for this ribbon renderer. So I'm going to go to the material slot and I'm going to select this mi_ribbon and click this icon in here. And I'm also going to increase its width a little bit. So right now the ribbon width is 10 units. I'm going to increase it to maybe 50. And if I click play now, you can see already we have something much cooler than the original ribbon material. But we have one issue with this kind of setup, and that is for the distortion texture and the dissolve texture, we are both using the same noise texture, and that isn't really too ideal. Wouldn't it be nice if we have many options for us to choose, and by applying different types of noise texture in here, we can get a totally different look. So generally, to create a noise texture, we will use softwares like Photoshop or Substance Designer. But since we already have a texture baker ready, we can do that inside of Unreal directly. So the first noise texture that we are going to create is something called Perlin noise. So this type of noise pattern is named after the person who invented it, Ken Perlin, and it is used widely in games for different purposes. In this lecture, let's look at how we can create a noise like this inside of Unreal. Go back to my level. I'm going to go to the textures folder. Inside of it, I'm going to create another folder. I'm going to call it noise. Double click to open it. Under this folder, I'm going to create another one. I'm going to call this Perlin noise. Double click to open it. Right away, I'm going to create a material. I'm going to call this m_Perlin base. In case you forget, in order to bake our texture, we'll need a render target and a material. So I'm going to create a render target directly. Go to textures and select this render target. I'm going to call this rt_Perlin base and double click to open this material. First thing, I'm going to change the shading model from default lit to unlit. The texture we are creating is a noise texture. We only need to have access to this emissive color socket. So to create a noise texture, we first need to use the node noise. And if I right mouse button click and start previewing it and change the preview mesh to plane, you can see what this node does is it generates a bunch of tiny nodes. And by tweaking some of the values here, we can get the result we want. So first, we need to plug something into the position socket. because the thing we are after is we want to bake out this pattern to a texture. For this position socket, we need to constrain it to texture space. And that will require us to use the no texture coordinate. And if we plug this into the position socket, you can see we get an error message. And if we use our mouse hovers over this, you can see it says cannot cast from type flow 2 to type flow 3. So the position socket is looking for a flow 3, but the texture coordinate node, it outputs a flow 2. And in order for this to work, apparently we need to add one more value to this, and we can use the no append to do that. So I'm going to use the no append vector. And for now, I'm simply going to pass in another value, a value of 0, and plug this into the position socket. And after that, you can see that error message is gone, and we already can see some type of noise pattern. Alright, this is great. We're getting somewhere. And next thing we need to tweak is the settings inside of this noise node. So if you look inside of it, there are quite a few things that we can tweak, and it might look quite intimidating at the beginning. So let's do it step by step. So first thing, we need to choose the correct type to begin with, and we can do that inside of this function. Right now, it's set to be this simplex texture based, and in order to get the Perlin noise, we need to change it to this gradient texture based. And if you ever feel confused about what these functions can do, the description text here is usually a big help. So this gradient texture based can help us to generate the Perlin noise we want. So I'm going to select it, and I'm going to begin to tweak some of the values in here. So first thing, the scale here, this will directly determine the scale of our noise, and I'm going to use a number of 8 to begin with. And now you can see we're already getting somewhere. And since we will be using this noise texture inside of our VFX, and we are likely to scroll it, that means our noise texture needs to be seamless. And we can easily do that by using this node. So after setting the scale, if you go down, you can see there's an option for tiling. If you take this, and then the repeat size here, you can just set it to be the same number as your scale. So I'm going to change it to 8 as well. And this will guarantee that we'll get a seamless noise texture. Alright, after adjusting the repeat size, the next thing, I'm going to start with this turbulence. So I'm going to untake this turbulence, and you can see this is the result I get. And for this level, so this will directly determine the amount of details for our noise texture. If I change this number to 1, you can see my noise texture, it becomes quite blurry. And if I increase this value, I have more details for this texture. So generally, I think a number of 5 will simply do the job in here. And let's go down. So we have this output min and output max. This will determine what's the value for the output result. For this output max, a value of 1 is fine. But for the output min, for a noise texture, we generally want it to stay between 0 and 1. So I'm going to change this output min from -1 to 1. And the last thing we can adjust is this level scale. And you can see here it says usually 2. So I'm going to keep it at 2 in here. And we can directly draw this material to our render target. But before I plug this into the emissive color, I like to add 2 more nodes to adjust that. So the first node I'm going to use is the power node. So what this node will do is it can help us to adjust the contrast of the noise. So I'm going to hold down 1 to bring out a float, and plug this into the exponent socket. I'm going to give it a default value of 2. I'm going to start previewing this node and plug this into emissive color. And you can see this is what we get. If we want a higher contrast, we can just increase the value in here. Say if I increase it to 5, this is what I get. And if I decrease it to 1, this is what I get. So I'm going to keep it a default value of 2. And more than that, we can also adjust the edge sharpness if we want. And we can use a cheap contrast node to do that. So I'm going to give it a default value of 0 and plug this into emissive color. So this is what I get. And as I increase the value, say to 1, you can see I have sharper edges. And this might be the result you want. So I'm going to decrease it to 0.1, for example, and we can get a completely different look. So I'm going to keep it a default value of 0. And generally, for noise textures, we want to quickly create different variations. And to do that, we can set up parameters inside of this material. And by adjusting those parameters, we can quickly have those variations we want. So I'm going to hold down V on my keyboard to bring out a vector4 parameter. I'm going to call this random seed, and I'm going to put it into its own group. I'm going to name this group to noise settings and give it a default value of 1 for sort priority. So there are 4 channels, meaning we have 4 scalar parameters. And for the red channel and green channel, I'm going to name it to U offset and V offset. So same as our pen distort master, we can use 2 scalar parameters combined with texture coordinate node to adjust the offset of this texture. And by tweaking the values here, we can get the variation we want. All we need to do is combine these 2 values together using makeflow2 and use an add node to add to the texture coordinate and plug this into the append node. I'm going to give U offset and V offset a default value of 0. Later, we can adjust them in the material instance. And for the blue channel, I'm going to call it random pattern. So this value here can help us to regenerate a random noise pattern quickly. And all we need to do is plug this into the append node. And by changing the third value here for the position socket, we can quickly get what we want. You'll know what I'm talking about when we begin to adjust this value in material instance. Alright, I'm going to delete this node and I'm going to organize this pin. I'm going to drag it down. And for the last value for this random seed, I'm going to name it contrast. And I'm going to give this contrast a default value of 2 and plug this into the power node. And I'm going to delete this hard-coded value and drag this pin down a little bit. And the last parameter, so this will be the edge sharpness. I'm going to hold down S on my keyboard. I'm going to call this edge sharpness and give it a default value of 0 in here. Plug this into the contrast socket and delete this node and put it into its own group, noise settings. Give it a sort priority of 2. And just like that. Now I'm going to click apply and go back to my level. Right mouse button click, create material instance. I'm going to call this MI Perlin base and double click to open it. So now by adjusting all the parameters I just created, I can quickly create different random variations. So if I increase the U offset, this is a totally different noise texture. If I increase the random pattern in here, you can see I'm changing the patterns from my noise texture. And if I want a higher contrast, I can increase the value in here. And we can get a look like this. And if we want to increase its edge sharpness, we can tweak this value in here. But usually you don't want a value that's too high. So I'm going to try 0.2 first. And you can see this is what I get. I'm going to change it back to 0. And say now we are really happy with this pattern. We want to create textures. We can easily do that thanks to our texture baker. Go back to my level. In my level, I already have a texture baker in here. We can always go to the textures folder and drag out another. But I'm just going to use this one. So I'm going to click it, press G on my keyboard, select this blueprint. All we need to do is fill in this material to draw and this render target. We can go back to this Perlin noise folder, fill in this material instance. And for this render target, don't forget to change its settings. So I'm going to change it to 512. And 512, change this render target format to RGBA8 as RGB. And I'm going to fill in this render target. Now, by clicking this button, you can see we get ourselves a noise texture. And this is something we can directly use for our VFX. And if we want to have another one, that's really easy to do. By adjusting the values for this material instance, and we can get a totally different look. Now by pressing this button again, we get a different noise texture. And by decreasing the value for contrast and maybe increase the value for random pattern a little bit, and pressing this button, and we get a different noise texture. As simple as that. And these are the values I use for my noise node, and these are the nodes that I use inside of the material. So feel free to take a reference of it if you need. Always come back to this later you ever get stuck in creating the Perlin noise we want. And it's time for a challenge. So your challenge is, I'd like you to set up Perlin noise using the noise node and material instance. After that, create noise texture using our texture baker. Pause the video now and give this a go. Welcome back. How was that? Hopefully you already have different noise textures inside of your content browser. Now I already have 3. I'm going to create 3 more. So go back to my material instance. I'm going to decrease this contrast to 2, and I'm going to adjust the value for random pattern. Change the V offset a little bit, and click this button. And I'm going to quickly do this twice. Alright, now you can see in my content browser I already have 6 noise textures, and we got an issue right away. And that's the naming for these different noise textures. Of course, we can name them one by one by selecting it and press F2 and then type in the name we want. But that's just time consuming. Why waste our time on such repetitive tasks when a few lines of code can do this for us? So in the resources dropdown of this lecture, you should be able to find a zip file, download it, and extract it. Inside of it, you can find a U asset, and it's called VFX Naming Helper. So cut this U asset and paste it inside of your content browser. I'm gonna press Ctrl+V to paste it in here. So this is a blueprint that I created. And what it does is simple. It helps us to rename assets. Now, if you go back to your folder and select all the assets you want to rename, right mouse button click. You can see a new menu entry will be added when you do that. Inside of it, there are 2 functions that I created. So number 1 is this batch rename asset. After you select it, a window will pop out. So this can allow us to quickly rename all the assets we selected inside of our content browser. So for the prefix, T underscore is perfect. And for the main name, I'm going to call in Perlin noise. And for the suffix, yes, starts with 1 is perfect. I'm going to click OK. And now you can see all the textures have been renamed correctly. And this just saves time and make our life much easier. And another thing that I want to do, if you recall, we still need to manually disable this alpha channel. Since we are not using alpha channel, it can help us to reduce this resource size. And we can easily do that by selecting all of these assets, right mouse button click, and go to this asset actions. Go down to this bulk entity via property matrix. Open it. So this allows us to set all the selected assets property all together. So all we need to do is go to this compression and take this compress without alpha. And now all these textures will be set for us. If I go back to my level, open any one of them, you can see this checkbox will be ticked for us. And right now we can use these noise textures inside this pen distort master. So if I go back to my material instance, I'm going to select this T underscore polynoise underscore 1. I'm going to use it for this distort texture. Press this icon. And you can see now the patterns becomes differently. And I'm going to use this one for this dissolve texture and increase its amount to 1. You can see this is what we get. And if you need, we can always create more noise textures by this current setup we have. One important note here is it might be very tempting to set up a parameter to control the tiling of this texture. By doing that, we can have larger noise and smaller noise. The issue for that is if we use parameter to control the tiling directly, we'll no longer have seamless noise. The fastest way to figure out whether or not a noise texture is seamless, we can just adjust its offset value to see if this is actually seamless. So go try it out for yourself. You want to increase another parameter to control its tiling. You'll have to be extremely careful with that value. Otherwise, the noise texture won't be seamless. And if you still need a larger noise or smaller noise, you can go back to your material, and inside of this noise node, you can tweak the values for the scale here. Or you can even duplicate this material and change its name to something like Perlin big and change this name to Perlin small. And in that way, you can have different noise textures with different scales. And another thing that I like to mention is that, so if you right mouse button click and go to this scripting asset actions, there's another one and it's called fixed MI naming convention. So this is another script that I wrote. What it does is when we create a material instance from a material, say this m underscore pen distort master, if we click this create material instance, you can see by default its name will be m underscore and has the suffix underscore inst for it. And the correct naming convention for material instance should start with mi underscore. So if you right mouse button click and go to this fixed mi naming convention, click it. So what this does is it automatically removes m underscore and underscore inst for you. All we need to do is change the name in the middle. Again, this is just another tool to help make our lives much easier.
Hey, this is me from the future. So the VFX naming helper that you downloaded from the resources dropdown of this lecture will be an updated version comparing to the one that I use in the course. So the difference with this one is if you go to your material folder and you create a material instance and right mouse button click to go to fix MI naming convention, a window will pop out, so I added a few lines of code to make this tool more robust. And now, what you can do with this, if you want to change the material instance main name, you can take this, then type in the main name in here. So for example, I'm going to call this material instance test inst, then click OK. And you can see this is my new name with mi added and underscore inst removed. So this allows you to directly rename your material instance while fixing its naming convention. And if this is not something you want, you just want to fix its naming convention, you can easily do that by creating another material instance. Click this menu entry again, and this time what you need to do is untick this change main name and click OK. And now you can see the naming convention has been fixed. In the next section, we'll need to change the main name of the material instances a lot. So hopefully this tool can help you in saving some time for renaming material instances. Alright, back to the old main.
And I'm going to start using it when we need to create more material instance in the future. In this lecture, we created Perlin noise inside of Unreal directly. And with the tools and the knowledge we have now, there are more noise patterns we can create. And we'll be doing that in the next lecture. I'll see you in the next lecture. Welcome! In the last lecture, we successfully created these Perlin noises using the noise node inside of the material graph. And thanks to our texture baker, it's really easy for us to create textures directly from material. Even though now we have these different variations from Perlin noise, they're still the same kind of noise. Is there a way for us to create other types of noise so we can have different distortion and dissolving effect? The answer is yes. We can do just that. By tweaking some of the values from the noise node and choosing a different type of noise to start, we can get the variation we want. In this lecture, we are going to start with the Voronoi pattern. So this is the first pattern, the first variation that we can create from Voronoi. You can see we can create a caustics pattern like this. Sometimes this pattern works great for dissolving and even distortion. Let's look at how we can set this up. Go back to my level. I'm going to go back to this noise folder, create another folder. I'm going to call this caustics and double click to open it. The settings inside of that material will be quite similar as the Perlin noise. So I'm going to duplicate this Perlin base, select copy here, and go back to this caustics folder. I'm going to rename this to m_caustics base and double click to open it. So same as our Perlin noise, we'll need these parameters to offer us random variation. And all we need to do is change some of the settings inside of this noise node. So first, I'm going to change this function from gradient to this Voronoi. We're going to start with this. And you can see immediately our pattern changes. And I'm going to increase its quality from 1 to 4. And I'm going to decrease the number of levels. So I'm going to change it from 5 to 1. And you can see, as simple as that. Now we get ourselves this caustics-like pattern. And if you want some larger scales for the noise, you can change the number for the scale here. So if I change it back to 4, change this repeat size to 4 so that we'll have seamless noise, the pattern gets much larger. So I think the value of 8 makes sense in here. And all we need to do now is to adjust its contrast. So right now, the default value for the contrast is 2. Right after I change it to 4, you can see this is what we get. I think I'm going to start with 3 in here. And everything else is the same as the Perlin noise. And there's one more parameter that I like to add. So you can see the brightness of this texture is too high. And we can lower it down by using a divide node. I'm going to create a parameter. I'm going to call this decrease brightness and give it a default value of 2. quickly into this group noise settings, change the sort priority to be 3, and plug this into socket B. Plug this into emissive color. Now you can see this gets much better, and if we keep increasing the value for decreased brightness, say to 3 or maybe 5, this is what we can get. And I'm going to click apply, go back to my level, I'm going to create a material instance from it, and I'm going to use the function I created, fix its naming convention. So it adds mi automatically for me. Double click to open it. So this is what we get, and we can keep tweaking the values in here. Say now I think the brightness is too low, so I'm going to decrease the number in here, maybe 4 or 3, and I'm going to increase its contrast to 5 or maybe 4. And we can quickly change the patterns in here, same as our prolinoids. We can offset it. Alright, something like this. And I'm going to bake out this texture. So right mouse button click and select render target. And I'm going to name this RT caustic space. And change its settings. So change it to 512, 512. And this render target format, change it to this. And I'm going to find my texture baker, fill in this material, fill in this render target, and click bake texture. And you can see this is the pattern I get. So I'm going to quickly create another one. And I'm going to rename these two textures using the function batch rename, and I'm going to call this caustics noise and click OK. And right mouse button click, go to this bulk edit properties and disable their alpha. And just like that, we have more noise textures that we can use. So these are the nodes and numbers for the caustics that I just created. You can see it's quite similar as our prolinoids. If you want to follow along, you can pause the video now and go ahead and do this, or come back anytime in the future if you need to take a reference of this. Alright, the second pattern we are going to create is this cloud noise, and by tweaking some of the values based on what we currently have, this can be easily achieved. And this type of texture works great for distortion. So go back to my level, I'm going to go back to my noise folder, I'm going to create another folder. I'm going to call this cloud noise, and I'm just going to duplicate this M caustic space and this RT caustic space, copy them to this cloud noise, and in here I'm going to change their name. So this one, I'm going to call it M underscore cloud base, and for this, I'm going to call it RT underscore cloud base. Double click to open this material. So in order to get a pattern for cloud, we just need to change a few numbers and add one more node. So go to this noise texture. I'm going to keep everything at default. So same as the caustic, I'm only going to increase the numbers for the level in here. So increase it from 1 to 3. And we don't need to decrease its brightness anymore. So I'm going to delete these two nodes and plug this into emissive color. And you can see this is what we get. And all we need to do is we need to invert this value. And we can use a node 1 minus to do that. So what this node does is it uses the number 1 to subtract the original output. So originally we have a value of 1. Now the output will be 0. And if we have a 0, the output will be 1. And I'm going to plug this into the power socket. And you can see this is what we get. Some cloud noise, as simple as that. And we can adjust its value in here. So if the contrast is too high, we can lower it down to 2. Alright, I'm going to click apply and go back to my level, create a material instance from it, and fix its naming convention. Now we can start to adjust its values. And after that, we can use Texture Baker to create the texture we want. And these are my values and my nodes for the cloud noise. So feel free to take a reference of it if you need. I'm going to pause here for 2 seconds, then we're going to move on. Alright, and the third pattern that we're going to create today is this marble noise. With the ability now to create cloud noise and caustic noise, this is really easy to do. Go back to my level, I'm going to go to my folder, and I'm going to create a new folder. I'm going to call this marble noise, and I'm going to use this caustics as the base. So I'm going to duplicate this material, and I'm also going to duplicate this render target. Move them both to this marble noise and select copy here and change their name to m_marble base and change the name for the render target as well. Double click to open this material. So this is what we have currently. For marble noise, we don't need this decrease brightness. So I'm going to delete these two nodes. And I'm going to go to this noise node. So currently our value for the levels is 1. I'm going to change it to 2. And you can see this is what we get. And in order to get the marble noise, it's actually very similar as our pen distort master. We need to use some noise to distort these patterns. So I'm going to use another noise node to do that. I'm going to right mouse button click and type noise. So this is just another noise node. And first thing, I'm going to plug in a texture coordinate node with a value of 0. So use append vector to append a 0 to it and plug them into this position socket. And right mouse button click to preview this node. So currently this is what we get. I'm going to change its type from this simplex to gradient. So Prolin noise, I'm going to change its scale to be number 4 and cancel this turbulence. Take this tiling, give it a value of 8 for repeat size as well, and change this output min to 0. And you can see this is what we get. Now by simply tweaking the values for levels and the scale here, we can get a very different result. So I'm going to start with 4 in here. Then I'm going to add this noise to the position input of these values. And I'm going to use this noise to distort this pattern. So I'm going to use an add node in here. Plug this into socket B. Plug this into socket A. And start previewing it. Now I'm going to plug this into the position socket. And you can see this is what I get. This is very similar to curl noise. So if this is something you want, you can go with this. And the theory behind it is the same as our pen distort master. We are using a noise to distort another noise. So right now you can see the distortion is too strong and we can always decrease it by using a divide node. So right now I'm going to give it a hard-coded value of 3 and plug this into socket A. And there you go. We have our marble noise in here. And you can use this technique to achieve many different interesting variations. So now if I change the numbers for the levels here, so this number here will determine the details of our noise. If I increase it to 6, you can see we get much more details for all the marble noise. And if I decrease it to 1, and this is what we get. So I think a value of 6 is reasonable in here. So some marble noise like this is perfect for distortion and sometimes even dissolving. So these are the nodes that are used to achieve marble noise, and the only difference between this app and the other noise app is before plugging these values into the position socket, I use another set of nodes to distort this pattern. And these are the values that I use. So the values here are for the main noise in here. The values here are for the distortion noise here. Feel free to take a reference of it if you need. I'm going to pause here for 2 seconds. And it's time for a challenge. So the challenge is, I'd like you to create those different noises that you just saw. So there are acoustics, cloud, and marble noise using the noise node and material instance. After that, I'd like you to use the noise textures you created with our ribbon renderer. Try to see what works best for distortion, what works best for dissolving. And with the knowledge you have now, you can create your own noise variation using the techniques that you just saw. Pause the video now and give this a go. Welcome back. How was that? Hopefully you already have a lot of noise textures inside of your content browser. So I created these 3 marble noises using the values that you just saw, and all I did was I went inside of this material instance and I tweaked the values of it, and this is what I get. And I also created some textures for cloud noise. Now that we can always come back to create more if we need. And now we can use these textures for distortion or dissolving whenever we see fit. So I'm going to go back to this Niagara system. I'm going to click this edit static bin. I'm going to increase its width quite a bit. So instead of 50, I think I'm going to increase it to 100 so that we can see better. Then I'm going to go to where it is located. So click browse to asset, open this material instance. Now I'm going to swap out these noise textures. So for example, for the distortion, we can use our marble noise. So I'm going to use this one and fill it in here. And you can see this is what we get. And if right now you think the strength decrease amount is too much, we can always decrease it. So maybe to 5. And I think I want it to move faster. something like negative 0.5. Yeah, something like that. And for this dissolve texture, we can use either Perlin or cloud or caustics. I'm going to try this cloud noise for now and increase its value to 1. So you can see this is what we get. Or we can try this caustics in here and fill it in. And you can see this is what we get. We have larger holes on this VFX. I think cloud noise works better. So I'm going to fill in this cloud noise. Yeah, something like that. In this lecture, we created different noise patterns all inside of Unreal. And these are just a few examples that we made. There are a lot more variations that you can create using the techniques that we've used. So if there's something that you are interested in, feel free, go ahead and do that. And I'll see you in the next lecture. Hey, welcome back. We covered quite a lot of stuff in this section. Now that you already understand all those different stages inside of Niagara and all those different modules, at which stage we should use which modules, and the difference between CPU sprites and GPU sprites. And we also created different types of VFX like this dandelion, this flamethrower, and this simple VFX using Mesh Renderer. Created our custom meshes inside of Blender and apply these custom textures on it. And we even bake out that texture ourselves. And these are all the important skills and knowledge you need to have in order for you to create more VFX in the future. Now, before we move on, there's one issue that I like to fix, and that is related to the noise texture. So I'm going to first duplicate this demo display. I'm going to change its name to noise test. So while I was making my marble noise, I made a mistake and it's no longer seamless. Another way that I use all the time to test whether or not a noise texture is seamless is I simply scroll it. So I'm going to go back to my textures folder. Inside of my noise folder, I'm going to create a material. I'm going to call this m_noise test. And what this material needs to do is simple. I'm going to first change its shading model to unlit and bring out a texture parameter 2D and bring out a panel node and give it a hard-coded value of negative 0.1 for the X and plug this into the UV socket. And I'm going to swap out this texture with the noise textures we made. So I'm going to first test this Perlin noise. So I'm going to select this T_Perlin noise 2, assign it to this texture parameter and hit apply. After that, create a material instance from it, fix its naming convention, and drag out our plane, this SM plane face camera, and assign that material instance to it. So I'm going to select it and assign this material instance. And I forgot to plug this RGB into emissive color. So click apply. Now you can see we're slowly scrolling this texture, and this texture is seamless. So this works great. But for my marble noise, if I select any one of them and assign it to this texture parameter, you can notice there's this obvious seam in here. And this happens to every one of my marble noise. So if I use this one, you can see I have the same issue in here. And the reason for that is I made a mistake when using the noise node. It comes from this noise node. For the scale here, I give a value of 4, but for the repeat size here, I give a value of 8. So they should have the same value. If you spotted this, great job. Be very careful with these numbers here, otherwise you won't be able to have seamless noise. Now if I click apply and go back to my level, I'm just going to quickly create another one. So click this texture baker and assign this material instance to it, assign this render target to it, click bake texture. So this is the new one that I created. Let's test out this one. I'm going to open this material instance and go back to my marble noise and assign this new one to it. And now you can see that seam is gone. So be very careful here when you are using the noise node to create noise textures. Make sure those numbers align with each other. Alright, now with all the resources we have and all the skills we have, in the next section, we're going to create a lot more VFX using the things we've learned. So when you are ready, I'll see you in the next section.